Hey, welcome everyone. Hey. Hey everybody, welcome to Bitcoin++. Just a little bit about where we started in Austin a few years ago. We've been a lot of places over the world, and this is our first time out in the Far East, so very excited to be bringing you Sovereignty Edition here in Taipei, Taiwan. So welcome everyone to our first ever East Asia conference. We wouldn't be here without the help of a lot of people, including our sponsors. So big shout out to NIDIG and the Human Rights Foundation for making this year possible. Also want to give a shout out to our workshop sponsors, Stackworks. So thanks to them for making our workshop space possible this time, and Base 58. But, you know, events like this aren't possible without the community, so I'm very excited to be, thank you to the BitDevs, local BitDevs for bringing us here. Evan's going to say a few words about Bitcoin in Taiwan and what it's like being an open source developer over here. So everyone give a big round of applause to Evan Lynn.
Hello, everybody. Welcome to Taipei. I've been asked to kick things off because apparently I was the one who convinced Lisa that Taipei was a very good place to have the very first Bitcoin++ conference. Unfortunately, we can't remember how exactly that happened. It's okay. So my role this morning is more ceremonial other than practical because I've been away from Taiwan for the past year or so working on Frostnap. But I do know is that when I left Taiwan, there was a very tiny focus on technical Bitcoin aspects in Taiwan. But there's, you know, on average, it was like 5-6 people per session. But I think the timing right now is very good. There's a new Taiwan Bitcoin hub, and I've heard that we got a new venue for BitDevs, and there's been consistently a lot more people coming. And now we have this conference here, so thank you all for coming to kickstart this new era. And my final thing is, Bitcoin has a long tradition of very loud arguments, and it's often about very small pieces of data. But underneath all that the question that really matters is the same. How do you build things that keep working no matter what? So thank you all for coming. And thank you, Lisa, for organizing.
Thanks, Evan. Thank you. So thanks, Evan. We're really excited to be here in Taipei. I just want to say a few things about why sovereignty. So for every Bitcoin++, for those of you who aren't familiar, we always pick a theme. This is our very first ever Sovereignty Edition. So really excited to be covering sovereignty. You might be thinking, okay, why is sovereignty important for Bitcoin? I wanted to kind of give maybe a little bit of background about what I think about when I think about sovereignty. One of the things that maybe is the most obvious is running your own code. So having your own hardware, being decentralized, having the ability to run software on your own machine. There's actually like an entire movement of thinking about freedom and software. It's called FOSS. So maybe, how many of you have heard the saying, free as in freedom, not as in beer? So most everyone, right? So this comes from the free open source software kind of foundation or movement that happened, I want to say, back in the 60s or 70s, coming out of MIT in Boston. How many of you are aware of the 4 essential freedoms, however, that this software organization came up with? So a few less people than have heard about the free as in freedom, not as in beer. So I thought I would take the opportunity to walk us through what the 4 essential freedoms of free software are. The first one is freedom to run the program as you wish for any purpose. So this means that you have access to a software program and that you're able to execute it on, ideally, your own machine. So you're not relying on a third party to execute the code for you. You have a copy of it or running it locally for yourself. So that's freedom 0. You can tell we're dealing with software engineers because they started the count at 0. Freedom 1 is the freedom to study how the program works. and change it so it does your computing as you wish. So in order to be able to access this freedom, this means that you must have access to the source code, because the requirement is that you have a program, it's executing on your own machine. That's freedom 0. Freedom 1 is that you have to be able to change it so that it can do whatever it is that you want. Freedom 2 is the freedom to redistribute copies so you can help others. So this is the idea that you have a copy of the software, you must be able to make a copy of it and send it out to others. Without this freedom, it's not actually free software. I would argue that you should just be able to redistribute copies, and that you don't really need an excuse of why you want to make a redistribution. You should have a copy of the software, you can make the changes to it and send it out. And the last freedom is that you, of course, you can distribute the copies of the modified versions to others. So just as a recap, you have software that you're able to run on your machines, you can make changes to it, and then you can send your modified version of the software to anyone else that wants to run it on their own machines. So the 4 essential freedoms, again, kind of as a summary. You have the freedom to run, copy, distribute, study, change, and improve the software without having to ask permission from anyone. So that's new information to anyone here? Everyone's like, some new people? OK, cool. But most of you maybe have heard of this. So this is whenever you get down to FOSS, this is what free and open source software really means. These are the 4 freedoms, or the 4 tenets that you look for in software in order to be able to call it truly free. So when we're thinking about sovereignty this week, what a better venue to do it at than a Bitcoin conference, where running Bitcoin code and software is something that everyone here has the opportunity to inspect the source code, to run it for themselves on their own machine, make changes to how Bitcoin core works, and then ship it to other people and have them run it. So that is, I think, in some sense, a true definition of sovereignty. I think that Bitcoin, however, kind of adds one additional element to the FOSS freedom stack. And I think a lot of the projects that I've invited here to join us and present this week represent what I think is kind of an extension of that. And that is the ability to hold your own keys. So in Bitcoin, not only do you get to run the code, modify it, redistribute it, have access to the source code, but you also have the ability for my financial system. So the thing that the Bitcoin software, when you're running it, gives you is the privilege to own your own keys and to have your own financial freedom. So Bitcoin, I think, takes this sovereignty idea out of the realm of just pure software into the social and value realm, where we have the ability as Bitcoiners to transact with each other freely because we have true, not just sovereignty, but financial sovereignty. So a big thank you for all of you for coming out today. Really excited to hear about your projects that you're working on, both in the sovereignty sense of FOSS, but also in the financial sovereignty side with the projects that you're working on in holding Bitcoin and transferring value from peer to peer. Great, I think that's the end of this. So that's our episode, my talk on sovereignty. Before I set you free to go find other talks, oh, that's interesting. I have a few announcements to make. First one is a little bit of orientation. You all made it to the main stage, good job. I know that there weren't, okay, that's the second thing. Hackathon, let's talk about the hackathon. We're gonna have a kickoff tomorrow morning for the hackathon, but I just wanna orientate everyone before we get into it. For those of you who this is your first Bitcoin++, or maybe it's your second or third one, you should know that for the hackathon, a lot of people look at that and be, well, I work on a software project, or I'm not really a coder. Is this really a project for me? The answer is yes. Everyone hacks at the hackathons. We've dedicated a lot of time tomorrow to give you the opportunity to find a team, sit down with some new people, maybe work on a project that you're not used to. We really encourage people to use any and every tool at their disposal to execute on the idea that they come up with. That includes vibe coding tools, et cetera. So this is a no-holds-barred competition, and we really encourage all of you to participate and come up with something, even if it's a small idea that you're like, OK, this isn't going to win me anything. We'd love to see what you have. Actually, one of our winners in Austin this year won with a slide. He got most ambitious with a slide deck presentation, and then he gave a presentation with his actual completed code like a few months later at an event we did last month. So slide decks are also completely acceptable forms of presenting. The reward for this one is going to be 5 million Satoshis in prizes. Thank you to all of our sponsors for helping make that possible. OK. Any questions about the hackathon? I think we're good. We're going to have a whole kickoff tomorrow, so all of your questions, et cetera, can be answered then as well. OK, last few things. I can't remember what else in the slide deck. This is a map of the venue. I know it's a little confusing. You have made it here at the main stage. Congratulations. For those of you who want to go to the workshop stage, that's going to be around the corner at Building F. So you're going to exit here and walk all the way around, kind of all the way in a loop around to Building F. This section in the middle, can you guys see that? Yeah, this is like the gift shop, et cetera, here, and you just keep going a little bit further. There's bathrooms in F, and then there's also bathrooms inside Building I. So if you need to use the restroom, et cetera, it's here. Also, I have to issue an apology. I said there would be breakfast, and I lied. I'm sorry about that. We'll have coffee and tea in the morning and the afternoon, and then there will be lunch boxes here around noon, so we will have sandwiches for all of you. But I reused some copy on the website, and I apologize for that. We have a no photos policy. Of course, it's totally fine to take pictures of me. I'm being recorded, and everyone who's on stage, I think, unless if you're a speaker and you don't want to be recorded, hit me up and I'll let people know. But in general, no photos of other people in the space. We like to respect people's privacy to come to events and remain anonymous. Of course, if you get people's permission, you're welcome to take photos. But as a general policy, keep your cameras pointed at the stage. We have a Telegram group where we're posting information, including info about after parties, et cetera. Currently, I think the only thing we have planned is on Wednesday. We're doing an opening of the Bitcoin Hub here in Taipei, so very excited we all get to be here for it. That'll be Wednesday night. On the Telegram group, I think that's everything that I've got. Cool. Great. Well, I hope everyone has a really amazing 3 days here in Taipei, celebrating sovereignty and Bitcoin. We're going to take a quick 10, 15-minute break that'll let us set up for the first talk here, and then also give people time to make it over to the workshop stage if you wish to see what's happening over there. Welcome, everyone, to Taipei. I can't wait to work with you guys for the next 3 days, so thank you for coming. That's it. All right.
Bitcoin Plus is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin sovereignty. Run your own node, hold your own key. Bitcoin is freedom, peer-to-peer, on-chain and off. Meet the sovereign builders of tomorrow.
Excited about having Bitcoin++ here in Taipei, not only because we get amazing local talent, but also some imports from the country next door. Nicholas Dorier is famous for shipping what I think is the premier sovereignty tech for people that want to accept payments, BTC Pay Server, and he's here today to talk to us about NB Explorer and why everyone should build on it. So let's give a warm welcome to Nicholas. Thank you.
Thanks a lot. So today, actually, I didn't want to talk about BTC Pay Server, but more something that is under the hood of BTC Pay Server, that a project that many maybe never heard about, but that BTC Pay Server rely on. And I believe it's a project that you, as a developer, can be very important for anything you build on top of Bitcoin. So this project is called NB Explorer, and it's a UTXO tracking and wallet management server. So I will go in a bit into the detail what it means. and what problem it tried to solve. So just a small history about this project if you're not aware of it. So I started it in 2017, and actually started as a, I'm sorry, Blockstream, if you're here, but as a shitcoin project, in the sense that it was based on elements, so liquid in a way. And it was for a conference that wanted to present a multi-asset wallet in Japan, basically. And I needed to do a block explorer for that, for the wallet, for the mobile wallets. And I started doing this project called Element Explorer for this conference. And so I made it. It was a bit clunky, but it kind of worked good enough for a conference that it was just a proof of concept. And after a few months later, there was kind of the blockchain war happening, and I wanted to create BTC Pay server, and I was like, okay, why don't I reuse this project? I change it just to be Bitcoin focused instead of liquid or elements. And I renamed it NB Explorer, like NB, it's like NBitcoin, what is another library I wrote in .NET. That means .NET Bitcoin, basically, NB Explorer. And I use these projects to build upon for BTC Pay server. For a long time, this project, I had my own internal homemade database. That was the worst idea in my life. Trying to work away from this design took me a while. So I changed it to a Postgre backend, and it makes all the difference, and I will talk more about that. So where NB Explorer fits in the picture, it doesn't attempt to replace a full Bitcoin node. You always need a full node. And NB Explorer depends on Bitcoin Core, on RPC, and P2P protocol. So it needs both of them. And in general, you have two ways of building your own business. If your business is not really related to e-commerce, then you don't really need all the overhead of BTC Pay server. You can just use NB Explorer and build your own business on top of that. If you are really focused on your own e-commerce, then I will advise you to build on top of BTC Pay server. It's more adapted. But I think most of you here that will be present for the next few days, you are, I think, more focused on not e-commerce stuff, or like more a bit lower level kind of Bitcoin development. So I think NB Explorer is kind of the right abstraction for you. So why other solutions are terrible? So why I created a NB Explorer? So for a lot of time, I tried to depend on Bitcoin Core wallets for doing my own work. And Core wallet at the time, now it has gone way better. But at the time, it was very bad support for read-only wallets. And like, if you wanted to restore a wallet, you needed to rescan the chain from the beginning to find out your addresses. If there was too many transactions, it was starting to slow down. Like the API was not really adapted to make query on large wallets. So as well with BTC Pay server, I wanted it to be, of course, main focus is on Bitcoin, but so NB Explorer is built on one library I create that's called NBitcoin, and basically with the same code you can support many forks of Bitcoin if you want. So I think it was a good idea to do NB Explorer because you could support multiple coins with one server with multiple wallets. So that was the idea. Other alternative like Electrum, like same thing, when there is too much address, it kind of explode. And it was not in C#. I really like C#. Like when I arrived here, I was a bit stressed because it's the first time I do a presentation on a Linux desktop. So, but I still didn't migrate it from C#. I'm sorry. So I needed to build my own stuff. And also, other solutions were very big because you needed the full blocks, you needed all the blocks, and you needed the transaction index on Bitcoin Core. And this was making hosting BTC Pay server very expensive. So my solution, I wanted it to work on Prune node, just to keep the cost down for merchants. And at the time as well, there was no BIP32 support on Bitcoin Core, or very bad. So yeah, for all this reason, I created NB Explorer that gave me more freedom. Also, I don't know if some of you like contribute to Bitcoin Core, like getting anything merged on Bitcoin Core takes lots of energy, so I feel it better to do my own stuff. So why is Samsung? So it's BIP32 native, so it will work very well. Very important, so this is really an infrastructure tool, so I don't expect you to expose it on internet. It's really, you build your own service and you keep it on your own like local network. It's kind of free infrastructure server. And I encourage you, when you want more refined requirement for your app, just get the data directly inside the Postgre database. I will show you quickly later, but the schema is very clean. It's very easy to do your request on that, and it will work great, whatever the size of your wallet, and so it's very flexible. Of course, there is a JSON API with a Swagger documentation, so you can generate your mock on any language that you want. It's very easy. It works with millions of addresses. One of the biggest users is Namecheap. So Namecheap is using BTC Pay Server to accept payments. They reach a point, I don't know now how much they have, but at one point they have 100,000 UTXO. And the Explorer was working just fine. So it's really scaled nicely. If you're interested into Liquid, there is also the multi-asset support on that. Of course, multi-tenant. You can have as much wallet as you want on a single server. And very interesting, it doesn't require synchronization with since Genesis block. So you really start your Bitcoin full node, you wait it's synced, then you start BTC NB Explorer, or NB Explorer will wait by himself. You don't have to do it manually. And once it's ready, that it will just work. You know, you don't have to wait any synchronization of anything. So there's a few exchanges that use it. So one passed by my mind is Bitbank, for example, in Japan. Another big service that is using it, Bitrefill. Bitrefill, from some of you know, that's the backend for their wallets. I use it. So because I use it, I have strong incentive to make it work and to not break things. So as a developer, it's very important. And the way you use it actually is kind of easy. So you have an Xpub that represents your wallet. You call the API, you say, I want to track this Xpub. And then after, every time you pass your Xpub and you say, OK, create me the PSBT, get me all the transaction, get me the balance. If it's a wallet that you want to restore, you can say, OK, rescan the UTXO set. If you rescan the UTXO set, it will rely on Bitcoin Core scan UTXO set call. And of course, you will lose the history, but the user will get back their balance and will be able to spend from it. So it's very easy. And if you have really more advanced use case and more advanced queries, it's Postgre behind the scene, just query the Postgre. It's super flexible, I love SQL. And actually, all the matching of blocks and transactions, it's entirely done in SQL, so it's very fast. And I'm only indexing what you're tracking. So the data is very small. It doesn't grow over time. So yeah, it's basically NB Explorer is really two parts. In a way, there is the indexer part that is in .NET that downloads the block from Bitcoin Core. Then I put it in a SQL format, and then I just push it to Postgre. And Postgre inside there is stored procedure that just see where is the match and include them in the database. So actually, if you are really motivated and you really don't like C#, that I know some of you don't, you can just drop on all of that, just take the Postgre schema and build your own stuff on it. I think it's possible as well. I will not do that if I were you, but it's something you can do. I think there is lots of rejig that you can reuse as you want. There is lots of views as well that I created that make things easy. So yeah, typical indexer, he receives the blocks. When there is a new block, he inserts in the blocks table. Then he puts a list of ins and outs of all the transactions inside the blocks, and it call one stored procedure, and then it just like put everything in the database directly. So it's kind of very easily. So I will not go through too much to the detail of the schema, but just the schema is very familiar to anybody that is familiar with Bitcoin. For example, this is a descriptor table with a descriptor script. So Output descriptor, for those who don't know, like in Bitcoin Core, it represents how to generate a set of addresses for a wallet. So what we call descriptor in NB Explorer is a bit more general because the concept of output descriptor was not really existing when I created NB Explorer. So we have kind of our own format, but I will show you, or we support other formats as well. But it's kind of very easy to understand schema. So for example, you have descriptor script to get the script of all the descriptor. You have the wallet table. Each wallet can have child wallets, so you can have a kind of hierarchy of wallets and ask for the balance, for example, of a whole group. So imagine that you're a company, you have many, how can I say, branch. You can create a wallet for each branch and then put them on one big wallet for the whole company. For example, it's something that you can do. You can get the script of all the wallets. Like, I will not go too much into the detail, but it's very easy. You have a block table, a block ticks table, ins, outs. Like, as Bitcoiners, you will figure out very quickly how it works. Like, nothing special on that. For example, if you want to get the wallet, all the UTXO of a wallet, it's a real simple SQL query. Of course, once again, we have the JSON API if you want it, but just so you know, you can just query directly the table. For the balance, you can just get the wallet balance like this. Demo, I don't think I will do all the demo, but I wanted to show you just quickly. What was it? So if you go on the website on NB Explorer, like on the GitHub, so we have a documentation where we really document all the different tables, what are the main concept behind it, and like I said, we expose lots of different views. So I know you cannot really see, but for example here, get wallet recent. So get all the recent transaction of a wallet, for example, all the UTXO, like. It's very familiar to Bitcoiner, the unused script right now. So it's very familiar to Bitcoiner. And one more thing I want to cover. I said that we support Xpubs, but in general we support descriptors. And what do I mean by descriptors is we have lots of different formats. So this is typically the old formats. So if you want, for example, to track just the SegWit addresses of an Xpub, the format is just the Xpub. So it's our format of the descriptor. If you want to P2SH, we have our own formats like -legacy if you want the P2PKH. Like, all of this was existing before Bitcoin Core did this output descriptors things. So that's why we had our own format for that. We support Taproot, but more importantly, I think I documented it a bit here. But more importantly, we support mini-script policies. Yes, that was the Liana guys that were pretty really wanted this. So I think it's lots of experiment to do on that, so it's supported. I'm planning to support as well silent addresses at one point with silent payments. But my only problem with it right now is how to restore easily. But I think it's not that much a big deal for me to implement it. So I think I will do it at one point. There is some demand for that. And what else? Yeah, you have, when you start the you have as well access to a Swagger file with all the different endpoints, so it's very easy to understand what's going on, or like how to do your own clients. It's also very easy to start BTC NB Explorer. If you have Postgre running on your machine and Bitcoin Core running on your machine, you start it just detects the settings automatically, so it's very easy to start. So yeah, that's about it, what I wanted to present you. And like I said, I think it was the right conference to present that, because like more, mainstream conference. It's going too much deep in the weeds, but here is Bitcoin Dev, so I thought it was a good opportunity to talk to you about NB Explorer. That is really important project for BTC Pay Server, and I think for you as well in the future. Thank you. Do we have time for a question? I don't know. Okay, yeah, I rushed it through. We still have time. We still have some time left. So, is there any question on NB Explorer? Sorry?
When?
Rare Pepes. Rare Pepe. Which kind of on what kind of protocol is it already? This one. Counterparty. Yeah, sorry. We don't do that. So we support multiple assets, but actually what we call multiple assets is basically just liquid assets. Yes. But technically we could do, but yeah, I won't spend my time on that. Okay, so if there is no question, I will be here all the days anywhere. You can just ping me directly. And also, yeah, from tomorrow I need to go back to Japan because there is Santa Claus that passed to the school of my daughter, so I need to be there. And but I will still be around. You can DM me directly on Twitter or directly on chat.btcpayserver.org. Or on Twitter, I have my DM are open. So if you are doing your hackathon and you want to ask me a question on NB Explorer, I will be there as well. Okay? Perfect. Thank you.
It's a little bit early. I think digital signatures are really cool. It couldn't get colder than Frost, though. So
nice.
Very excited to have one of the cryptographers who was early to understanding Frost, I think, do one of the first implementations in Rust, perhaps. He's been working on how to bring this very cool digital signature technology to consumers at Frostnap, and so very excited to have him here today talking about some of the challenges of translating cryptography into the user space. So give it up to Lloyd Fournier. Thank you.
Thanks, Lisa. Yes, I'm really excited today to talk about Frostnap, the design and implementation of Frostnap, give a technical talk. I think this is the first technical talk I have given on Frostnap. And I'm really excited to do it. I asked myself, what do you guys want to know about, actually? What does the audience actually want to see? They probably don't want to hear stories because we're a technical conference. They might, some people might, but I think it would be better if I just gave you an autistic stream of consciousness of technical details. So that's what I came up with. It's a very technical talk I've got here today. I'm glad you guys didn't have breakfast because I don't think some of you would be able to handle it too well. I think it's fine to call myself a cryptographer as long as it's only like semi-serious. Most of the time, I actually spend, resizing buttons and stuff nowadays and making things build on Mac. That's probably where I spend most of my time. But I do know I'm a little bit dangerous with cryptography, and that's really what the talk will be about. It's like the tricks we added over the existing cryptography to make it a good UX. Basically, UX hacks down to the mathematical level. Okay, so I'm going to just quickly tell you what Frost is if you guys don't already know. So it's some kind of acronym there. It's a T of N threshold signature scheme. It's a sort of mathematical replacement for multisig. I guess you guys are aware you can condition the spending of Bitcoin on signatures under multiple public keys rather than a single public key, so multiple people need to sign or multiple devices need to sign. Frost is an optimized version of Bitcoin multisig. You have, instead of having multiple keys on chain, you have a single key on chain, but each device or each party holds a different secret share of that key. And any T of the parties, so 2 in a 2 out of 3 setup, would be able to produce a signature. And that signature is actually indistinguishable from a normal single sig signature. So it's just a normal signature that goes on chain and a single key, so no one can even tell that you're using multi-sig. Okay, so we create BIP340 signatures, that's taproot signatures on chain. That looks like it's a normal signature, but it's actually a multi-sig, okay? This is how it's evolved, sort of from the research part of it. There was Frost by Kolmo and Goldberg, and there's also Musig 2 at around the same time. They both came up with the same kind of trick. This was for N of N schemes, and this was for T of N. Musig 2 was a useful contribution because it had a better security proof, but the Frost, Kolmo and Goldberg also came up with fixed their original security proof, I would say, in this paper, proving Schnorr assuming Schnorr. And then eventually, Chow et al., which also includes some of the Blockstream research people, produced this practical Schnorr threshold signatures paper, which is what really our implementation is sort of based on, or at least that there's then a specification called the Chill DKG specification made by Blockstream Research based on that paper with a few extra tricks added. And then finally we have Frostnap, which is based on that and is adding our own tricks. So I gotta briefly, here's where the math starts. We're going to briefly explain Shamir secret sharing because not everyone is going to be familiar with it, but it's really cool. So, instead of having multiple public keys on chain, you would instead take a single secret key and you split it up mathematically. So you split it up in a mathematical space. For example, this would be a 3 out of 5. You want to do you need 3 signatures from 5 keys. You would take this A0, which is your secret key, and you would split it up across this parabola here. And every point on the parabola, you can think of it as a secret share. And so what you do is you take your polynomial or your parabola and you evaluate it at different points, and each point you evaluate it is a different secret share. And any 3 of the points on the parabola lets you redraw the parabola and figure out what A0 is, which is your secret. A0 is the thing with all your bitcoins on it, right? So what are the benefits of doing this, splitting up the key in this way? So we have, first of all, and probably the most consequential thing for you as an end user in a personal Bitcoin security situation is you don't have to have this descriptor backup. One very dangerous thing about traditional multisig, or legacy multisig as we like to call it, is that you have, if you have a multisig, let's say it's a 3 out of 5, you have 5 public keys on chain, and you have 5 devices, and each one probably has a seed word backup, right? Now, if you would think that if with 3 of those seed word backups, you would be able to get the funds, but actually you can't. If you only have 3 of the seed word backups, you will lose all your money. That's very unfortunate. The problem is you need to know what the other 2 public keys are to be able to find the funds on chain to be able to spend from it, because they are not, the raw public keys are not in the output, they're not in the address. They are only, you need to know how to reveal what is inside that address, and you need everyone else's public keys to do that. So getting 3 of the backups is not enough, and so we don't have that problem. If you have, with Frostnap, if you have 3 of the backups and a 3 out of 5, you have all the money. That's all you need. You don't need to know about anything else. That's because you're mathematically splitting up the secret, and so that parabola, you can still produce it and still get the main secret. Okay, so on-chain efficiency, of course, we've got a single signature, single public key, same cost as a single sig transaction, so less fees, and the privacy is better because you're not revealing what multi-sig you're doing. You can also do more funky things we haven't implemented. You can have multiple access structures. You can have a 2 out of 3 and a 3 out of 5 accessing the same funds. You can, and you can even add, for example, you can have a 2 out of 3 to start off with and even add a 3 out of 5 later on with different devices without moving the funds on chain, right? You can also enroll a new device. You've got a 2 out of 3. You could add a 4th one in there, add part of the same access structure. No need to move the funds on chain. No one can tell that you've done it. It's a pure offline operation. This is quite important for businesses, if they put out an invoice with an address, like give this much money to this address, and then, oh, while that invoice is out there, they need to make a personnel change, they need to get rid of Steve from the company, well, now you've got to change the invoice. You've got to call them up, sorry, Steve's left the company now, we're going to change the address for that invoice. With Frost, you can remove Steve without having to change it. So here is key, this is going to go through key generation and show what we did to make things a bit better. So key generation in Frost is everyone is doing a local Shimia's secret sharing, right? So they're all running that parabola sort of thing locally and splitting up a secret to everyone else. And then we sort of just adding them together. Okay, so this coordinator guy in the middle, he's taking everyone's polynomials or their coefficients of the polynomial, and the encrypted secret shares that are destined for each of the devices, adding them all together, and then finally giving them to the end devices. There's also this little proof. You need this proof to make sure that device 1 knows that their contribution was made, was included in the final result. And so then, after adding everything together, you get the aggregated polynomial. You get and every device is able to decrypt their secret share and check that they got the right one. And this is how it works in chill DKG. But this, I mean, you can imagine how do you do that protocol with wallets? There was these guys actually called Stax Wallet who very bravely managed to get an HRF bounty on making a mobile Frost wallet, and they actually did this all with QR codes. So they did the whole protocol all with QR codes, and it is a very time-consuming task to do every single round of the protocol with QR codes. So registering devices, every device registering their public key, every device message that every device wants to send, have a QR code, for that, and then everyone getting the final result, have another QR code round for that. It was a very difficult thing to do, so we didn't want to do this in Frostnap. So what we wanted to actually do was, well, just for a moment, just think about normal multisig. You've got to register all your devices and their public keys, Xpubs into the main wallet, and then you've got to generate the wallet and then export the descriptors, right, back to the devices so they can check the addresses. That's basically, it's still a little bit of work, and with Frost it would be impossible, or very difficult to do this because of how much time it would take, because there's extra rounds. So we really can't do what you do in legacy multisig. So we wanted to come up with a solution, so we came up with the daisy chaining solution. Is you take the Frostnap devices and you plug them into each other, and they all run it live. So they all run several rounds of the protocol all together, and there's no plugging things out and back in. And so that's our first UX hack to try and get this thing good. And now I'm going to go through a few more that we did that are more cryptographic, more in depth. Okay, so one of the really tricky things is this. What you would do in legacy multisig is you would have to check on every single device that they have all the same descriptor, right? So they all get the same addresses and they're all convinced they're part of the same wallet. Same thing you could say you'd have to do it with Frost, but what we wanted to do is come up with a really compact way of checking that. Not like scrolling through like very scary things, and not having to check big chunk of data and checking every little hex byte is the same as the other byte. So we came up with a way of producing randomness during the key generation that allows us to reduce the security check down to only 4 bytes. And so you can just see, you look at the device, you check that is the same. That actually allows you to guarantee that every device was part of the key generation, had its input included, and no one is trying to hijack it. If it wasn't for this VRF check, this verifiable random function that we used during the certification round of the protocol, you would have a big 32-byte hash that you'd have to check. So that's how much we care about you. That's how much we care about your eyes. We put in a lot of cryptography just to make that a very small check. And the other thing we did generation. So we are the first hardware wallet to do this. All other hardware wallets, I think, you get like a USB stick in the mail or something, right? And you just say, all right, generate me the thing that's going to hold my life savings on it, right? It's an interesting behavior, but it works because we have very good hardware wallet companies in the Bitcoin space. But what we don't do that with Frostnap, actually. We don't just let them generate keys. So even if we ship you 3 malicious Frostnap hardware wallets, the software on the coordinator, and of course it's all open source, it's going to add its own polynomial to the thing, right? So these guys are all generating polynomials, splitting up shares and sharing them, but the coordinator, he's going to add his own one also. He's going to add his own one, and that's going to be included, and that means that's going to be included in the main public key, this randomness. So these devices are not going to be able to generate a key that is owned by an attacker, whereas otherwise you would easily be able to do that. Now I'll go into signing. So key generation, we nailed that. We made it really good. Signing, basically our main task is just to make it as good. You know, we just want it to be, we want it to basically be the same as legacy multisig. You just go to different devices and you sign without having to worry about any of the technical details, right? So the difficult thing is this nonce problem. In Frost, you have to share these things called nonces up front into which go into each signature. When you're doing single sig or legacy multi-sig, which each device is doing that, but they're handling it behind the scenes, you don't have to worry about it whatsoever. They generate the nonces at the time of signing, but because all these devices are sharing a single signature on chain, you actually have to generate these nonces together. And this is one of the most difficult things to design around. So yeah, so the coordinator is aggregating them. And there's the real challenge, the security challenge, is that the devices must never reuse the nonces. And when I talk to people about Frost, they're often like, no man, you can't do that. The nonce management thing is too difficult a problem to make this thing secure. If my thing accidentally, or if an attacker is able to get me to reuse the nonce, then all my money's gone. At that point, it's a big risk. And indeed, it's a little bit of a risk, but we can address it. So just imagine this scenario. So device is signs, it's used a nonce, it's never allowed to use that nonce again, right? It's signed a thing, it sends the signature, but then it loses power. The device doesn't know if the coordinator received the signature. Maybe it lost power while it was transmitting the signature. The coordinator, even if it did receive it, could lie that it has not received it. So what we really want is that if the coordinator asks for the signature again, if it's the same message, and it's the same nonsense, just return the signature that has already been produced. So like save it. But if it's a different message and the same nonces, reject it. And you just guarantee you can never use any nonces you've already used. And so in the end, this is not like a deep cryptography trick. It's just shown that it's not so hard to do this. You can forget about data with the right hardware. So this is all you have to do, is you take the state at the beginning, is you're at nonce n, you get asked to sign, you take these 2 slots of flash memory, right, and you write the next n+1 into the 1 slot and write the signature. Now you've got the signature. Now if you've lost power in this state, you return the signature, right, because you're at state n+1. You return what's in slot B, but first you write it to A. And now A and B have been fully moved forward to the next state, and then you return the signature. So really, it's not so complicated to overcome this problem. Once you've gone to n+1 and both things are n+1, n is deleted from the universe. So you can never produce that old nonce ever again. You only ever return the signature once you get to that state. So with NOR flash, which is what you have on embedded devices usually, erasing is a real erase. It's definitely gone after that. There's no coming back. So we can actually guarantee what we need to guarantee here, and you don't have to worry about nonces. And so the next thing we've done is something that other hardware wallets have done, which is to do anti-exfil, which is really just the signing equivalent of what we did in keygen. We get the coordinator to get its nonces from the devices, the nonces they're going to use, but then it adds its own random nonce to it. Then when it goes out to sign, it's got this RC from the coordinator in there. And so the devices, no matter what they try and do, they cannot contrive the nonce. Now, contriving the nonce means like having R1 and R3 be very special, that those two devices are working together to leak their secrets and leak the money on chain, which is actually a very dangerous thing, a very dangerous attack. And there's this attack called darkskippy, darkskippy.com, if you want to check it out, that we developed, that shows how a device can, in pretty much a single transaction, can leak a full 12-word seed phrase just by messing around with those nonces, right? So we don't trust the devices to sign. Other hardware wallets do. They're just like, let's let this device produce the nonce and put the signature on chain. We do not let them do that, and we don't let them generate keys by themselves easier. So we don't actually let the device do any trusted operation. Anything that they're doing that involves randomness, where they're meant to generate randomness properly, we do not let them generate it by itself. We provably add in our own randomness. So we have this, we're the first hardware wallet that's not a trusted third party slogan. Terms and conditions apply to that, but it's roughly true, and I think it is an important fact that we don't allow devices to generate randomness by themselves. There's just no reason to do it. Well, there are some engineering reasons. I wonder if anyone knows, but the main reason why it would be hard for single sig things to do this, or other hardware wallets to do this, is that are not Frost-based, is that you can do it. And the nonce stuff is done by some other hardware wallets, but the key generation one is very tricky if you want to use BIP39 seed phrases. BIP39 seed phrases gets in the way of it because it's kind of a system where an individual device has to do that hashing of the entropy. And since that hashing is not a homomorphic function, it's very difficult to let other people disrupt what that device wants to do. It has to be trusted to do it by itself. Since we're in Frost and we're all doing key generation and all these things are being shared already, it becomes very easy for us to take this coordinator and disrupt any attack, because the coordinator is already having this stuff pass through it anyway. So yeah, backup and recovery. So when we started this project, I didn't think all that much about this. It turns out that making a hardware wallet and a Bitcoin security sovereignty system is like 80% at least backups and recovery. And that's where I spent most of my time working on backups and recovery and not cryptography. So we've done a good job. At the beginning, actually thought we could get away with not having backups and recovery because you've got multiple devices, right? You've got 2 out of 3 or 2 out of 4, and you've got redundant devices, so if one breaks, you just got extra devices. But then I realized that no one would buy that at all because you could have 4 devices fail. I know people have had a whole batch of devices fail, and so you do actually need backups, unfortunately. And so we did generate and craft a backup system that we're quite happy with in the end. So in the end, it actually just is some words. They're BIP39 words with a number on the front. That number is the share index, like where it was evaluated on the polynomial, right? So it could be 1, 2, 3, whatever. And then you got 24 words, which has the secret share. So that's the evaluation of the polynomial plus the polynomial checksum. I'll explain what that is soon. And then this 25th word, which is just the checksum over all the 24 words. So this polynomial checksum is a weird one. It's it's not really straightforward about what that is. But do you know, like when you recover even legacy multisig, there is this check that I've already mentioned. You have to kind of check that after you loaded all the seed words into each device, that you've got the right descriptor on each device, right? They all have agreement, because if you try to check addresses, you need to make sure that that device really is in the right multisig with all those other devices. If not, it could be in a multisig, but it could be in a multisig majority controlled by an attacker. You don't know what that laptop you're plugging into is doing or what it's exporting to those devices unless you check it against the other devices. We figured that this is actually a really difficult thing to explain to users and to get them to do it. And so we actually, and in Frostnap, it's even more like difficult to see that that's what you need to do. You need to somehow check an address on every device to make sure that the next thing you do is generate a receive address after recovering, that it is actually part of the wallet and not just something that the coordinator, your phone or your laptop, is lying to the device about. And so we put this little 8-bit checksum in here just to sort of say, just because we really didn't know how much we care about this kind of thing. We don't really want you to go around and having to do all these manual check steps. It's a very weak attack. But this is how it works, is you restore everything from backup. The malicious coordinator provides the wrong public key, but it says, hey, your secret share is part of this public key. The device displays the attacker-controlled addresses, because that's the next thing you do, is try to receive funds. And then those funds are actually controlled by an attacker. So what we do is we put this 8-bit checksum inside the seed words, which just says, like, listen, you've got a 0.5% chance of actually pulling this kind of attack off, which probably means it's non-economical, right? Just a little a thing we threw in there. And so with backups, the reason we chose this approach, what our approach is that you're just backing up the secret shares, is because out of all of them, it seems like the best one. There are other things you can do. You can have like a cloud backup thing which stores the whole key generation. And that's actually what the Chill DKG spec gives you as a backup system. This is pretty much bringing back those descriptor backups, which we didn't really want to do. We didn't want to have some digital backup. We just wanted the seed words to be the thing. We could have added separate seed word access structures. So in other words, you have your main funds on your multiple on your devices, and then you have like different pieces of paper for backups. They're not backups of the devices, they're different backup access structures. So I have a 2 out of 3 for my devices, but I have a 3 out of 5 for my paper backups, and I give them out to different people. We thought this might be very confusing for users, though. There's lots of difficult questions about how you display those paper backups. If you're inheriting money or you're trying to recover money and you don't have devices to put the backups on, it's just like pieces of paper. It can be, you're left in a tricky situation. So in the end, we just have each device just has a backup of the secret that's on it. And it's just as simple as that. We used BIP39 words because people can't record BEC32 correctly. That's the encoding of addresses. And I really thought that at the beginning that BEC32 would be the cool modern way to do this. But in the end, actually, many people just write 5s like S's. And it's totally indistinguishable from each other, and many other letters. Some people write numbers that look like there's other numbers. Some people write letters that look like other letters. It's not really possible. The words is really a good mental checksum. And our main goal with this thing is actually to be able to really easily reproduce the code. So Frost has all this like magic stuff going into it, but the backup and recovery system is actually relatively simple. We are doing the Shamir secret sharing, but you can vibe code a Shamir secret sharing interpolation thing in Python very easily. And so you can describe to an LLM a couple of sentences, and it will actually reproduce the code needed to take the backups and get the money off them. So this is, I think, my final trick for today. It was quite a nice trick that I came up with, and this is the problem of not knowing whether backups are related to each other. You've got all these different backups, and you don't know if they fit together. Right? This could have been some backup you made for a different key, and now you've got it, and how do you know it's related to this key? You could put some extra checksum stuff, some labels on the words or in the words or something to make sure this is what that they're related, but that would mean extra words. And we don't want people to have to say, we don't say people like, write down 30 words, right? Because 25 we can get away with maybe, but 30 we're going to be pushing it. So what we actually use the mathematical structure of the Shamir secret sharing, the polynomial that shares it, we actually embed and grind a fingerprint into the polynomial. That means that there's a very small subset of polynomials when you when you take the secret shares and you interpolate them into the polynomial, there's a small subset of polynomials that actually are valid Frostnap polynomials. And so you'll know when you get the shares together whether they were actually together. So we're actually part of the same keys. This is what it looks like in the UX. You get like these three, you load in these three backups, and the system detects actually the 1 and 3 are part of the same wallet. But this one, 4 with Greg's one, was not part of the same wallet. So we can actually automatically remove that for you. So your task when you're recovering the funds is just to get the seed word backups and load them in, or devices, and just load them in as many as you have, as many as you want, and it will automatically, mathematically figure out which ones were part of the same wallet and which ones were not part of the same wallet. So in the end, with all these tricks, what do we have? So we've got a sovereign multi-sig wallet that recovers from a threshold of devices and or paper backups. It can be restored by like non-technical family members. Single on-chain signature and privacy, same as single sig. Most of the effort goes into hiding the complexity so we can at least match the UX of traditional multi-sig. But on top of that, we get some big wins. So no descriptor backups, a 4-byte security check, and not a trusted third party. So we're pretty happy with that for our first product, and we've got more things coming on the way. But that is it. And if there is time, I'll take questions, but otherwise I can get out of here.
Awesome.
Why can't we do 12 words instead of 24 words?
Yeah, it's something I've really tried to mathematically produce 12 words in between button resizings and stuff. It can't be done. Unfortunately, it simply cannot be done. It encodes a secret key, right? These scalars, these shares, Shamir shares are 32 bytes. And that is basically what you get with 24 words, is the ability to encode 32 bytes. I've tried to reduce it down. I've tried to come up with tricks. The tricks don't work. Nothing I can squeeze. There's nothing I can squeeze. I'll be very impressed if anyone can, squeeze it out so you have it like a 3 out of 5, and then instead of having 24 words, you have 24 divided by 3 words, and so you have like totally, when you get them together, like it's just 24 words in total. That would be so amazing. Yeah, the backup and recovery stuff is something I poured over a lot of time and effort in, and was not able to get that advantage.
So you said something about not liking descriptor backups, but what if I wanted to use Frost in a descriptor?
I think you. No, you can back up descriptor. Thing is, what do you want? You don't really want them to. What you want to be able to do is reproduce the whole descriptor just from the seed words, right? So if I can reproduce
Like if I wanted to do some funny mini script thing where I have like multiple different Frost keys inside a mini script, because why not?
Yeah, I think it's fine. You can do that, but like think about how do you reproduce each element of that descriptor, right? The key thing we're solving is that you have a 3 out of 5, right? You would in that traditional descriptor, you'd be like, okay, I got to reproduce all 5 of those keys. For Frost, you only reproduce 3 of them, any 3 of them, and so you're shrinking what you need to reproduce. Like hopefully, like the user's key is like some kind of multisig or something, and they just need to reproduce the threshold number, then all the other keys, like the static service provider key or whatever, can all be just reproduced by the software. And so they really don't need to actually have a descriptor backup.
On the same topic, so basically what you're doing is an equivalent of like, which one is it, like BIP 42? That's like, you know, kind of brute forcing with just the backups or with just the mnemonics. You can brute force basically what the wallet will look like. But this is actually the problem for wallets like us using descriptors, because users have been told basically they just need to keep their mnemonic, and then somehow their wallet will figure out where the coins are, and then they don't back up descriptors. So if someone wanted to use, again, a Frost, let's say in a Liana or whatever advanced wallet, and they're like, oh yeah, but I read on the Frost website that I don't need a backup of my descriptor, they will lose funds. So
why would they lose funds? Like
because if they don't have the descriptor of a wallet using Frost, but not just Frost, or not assuming kind of the equivalent of a single sig being brute forced by having the right derivation path, right? You're like, if they don't back up the specificities of their wallet, they will never find the funds again.
That's true, but I would try and design it so the specificities can somehow be reproduced or be grinded in. So like, if it's a service provider's key, then you can figure out which service provider it is. If it's like, what kind of keys would you use in a Liana system that you couldn't reproduce?
Right. So let's say I have a business, right? So between the team that is going to co-sign, as would be a multi-sig today, I use a Frost setup. Then after an inactivity of 3 months, we have the board of directors keys in a Frost setup. Then after 1 year, we have a 2 of 3 Frost setup of 3 different service providers that can be there as a disaster recovery. Do you want to like brute force every single kind of setup like this? Should it be enforced in a template? Because we don't want that. We want to leave the user define exactly what they want for their needs and not have any basic templates like 2 of 3 or 3 of 5.
Yeah, I mean, I would still hope that like in such board of directors situation, like the board of somehow one is going to have that backup somehow natively, because the board of directors have the key already, they can already just spend it, and so you could just, if worse comes to worse, you don't need that. So I would still try and avoid, for like individual users, try and avoid cloud backup kind of things, if you can. If it's not in your setting, it may not be appropriate. But for like, I think we're talking about mostly personal Bitcoin security here. Like this is like people, someone's passed away, they've been incapacitated, and now what steps do I have to do to reproduce the thing? And now that situation is where you really want to optimize for that. I think there are a lot of other situations where you don't need to optimize for that thing. So yeah, I think personal Bitcoin security, you should be able to grind it out. That's what I hope. Yeah.
Can I ask another question?
Sounds like we have a first descriptor debate lined up for later tonight. Okay, added to the schedule. Huh? Sage phrase stuff. Okay.
Hi, Lloyd. What are the downsides of Frostnap, in your opinion, compared to like a traditional 2 of 3 multi-sig or 3 of 5 or something else?
Yes, good question. I did have slides on this, so I was like, delete it. Downside's not fun, but glad you asked the question. So they usually happen in the signing part. Okay, so the signing bit is one thing is I didn't mention, but I should, is you have to choose which signers you're going to use when you start signing. Right? So it's like, I'm going to sign with Alice and Bob, or Alice and Carol, or Bob and Carol. So when you start creating the signature, you have to choose which ones it's going to be. You can't be like, oh, I go to Alice's house, and I was going to sign with Bob, but now I want to change my mind. I actually want to do Carol. You have to start again. That's one. Then the other one is actually, with this nonces stuff, we do have a limit on the number of inputs you can sign at once. So I think right now we have like 30, because I do 30 inputs at once, but there is some limit, right? The coordinator only has some amount of nonces. We could bump the number up to 50, just makes things a bit slower, 100, whatever, just makes things a bit slower, but there is some limit on it, yeah. Also, you don't know who signed. That's maybe another one, is like you can't figure out who it was that actually made the transaction. So if you're in an organization, maybe the 3 out of 5 on-chain, you can see all the public keys, you can see which public keys signed, and therefore which people made this decision, whereas Frost, you cannot, it's a single public key, single signature, you can't detect who it was in the organization that authorized that transaction just from the on-chain data.
So is it possible to sign a hardware sign remotely? Or do the signers need to be physically in the same location?
No, they don't need to be physically in the same location. You can definitely leave the Frostnaps in different locations and sign them one by one, leaving each one. But then, can you do it on the internet, basically, right? Yeah, yes, you can. We've done proof of concepts. I don't know, it might be something to do in the hackathon, Nick. We don't know. There you go.
There's a workshop this afternoon where they'll be doing it, and that'll be in the talks/workshop stage that they're building. And that starts at 1 o'clock, I think. Yeah, so after lunch.
All right, cool. Well,
Thank
thanks
you,
everyone.
Lloyd. Yeah, let's give big round of applause for Lloyd and Frostnap. Alex, you know. Cool. So we have one more talk before lunch. We're going to get Alex Gleason up here to present on sovereignty. So we've had conversations so far this morning from Dorier talking about MB Explorer, which is software that lets you have sovereign processing of blocks and understanding of what's in the blockchain so you can build your own wallets. We just had a great talk from Lloyd about the cutting edge of Frostnap, which is how you're doing key signing in multi-sig distributed ways. This talk from Alex is our first one talking about the sovereignty of doing open AI. So how many of you guys here use AI coding tools to produce code these days? Okay, is that like 80% maybe? All right. How many of you guys use open source models for coding though? Like less. Okay, it's just the front row here. This is Alex Gleason's team, I believe. Okay, so they're practicing what they preach, which is awesome. So super excited to have Alex Gleason here all the way from Texas, yeehaw, to talk about what's happening at Soapbox. And how they are bringing the future of AI in a sovereign sense to not only coders, but I guess like people on Nostr as well, perhaps. Great. I don't know how much more time I need to kill. We're going to have lunch after this, so this will be I think this is supposed to schedule to end around 12:15. We might go a little bit over, and then there should be sandwiches showing up at some point today here. And then we'll be back at 1 o'clock after that with our afternoon talks, etc. Cool. Looks good. All
Hello,
right.
testing.
All right, let's give it up for Alex Gleason from Soapbox. Thank you.
Hello, this is really open AI, not to be confused with open AI. Can I get a let's go? Let's go! All right, thank you. I'm just testing y'all. Thank you. All right, so 2025 has been a pretty big year for AI. AI has broken out of chat UIs and is now able to control your entire computer with simple prompts. And I've completely changed the way that I develop code with AI, and if you haven't, you're probably getting fired. At the beginning of the
Hello, hello. All right, there we go. At the beginning of this year, I was very convinced that the robots were going to kill us. Science fiction is real. Terminators are real. It was so over. As we speak, it's happening right now.
Hello, testing. All right, cool. Thank you. But increasingly, I became convinced that we are entering a new renaissance. Barriers are being broken. Just as much as AI is empowering big tech companies, it's also empowering individuals and communities. Right now, the truth is somewhere in between. Big tech companies are leading the AI race, and it's up to us to join that race too and prevent them from taking complete control. Bro, what kind of AI you got running in this joint? Yeah, okay. Mr. Frog is working on the technical difficulties caused by the new generation of technology. All right, are we back? Okay, cool. So in the 1980s, Richard Stallman started the free software movement while working at MIT's Artificial Intelligence Lab. What a coincidence. Stallman believes that if users don't control technology, then technology controls users. So he proposed these 4 freedoms that software must have for users to be in control. The biggest AI company, despite its name, offers none of these freedoms. And I think it's insulting that they call themselves open AI. That's why I think we should call them closed AI. There are also a slew of closed-source AI tools making up most of what we call the AI bubble. Building an AI model costs millions of dollars, but these tools are just wrappers around REST APIs. This is the place where I think regular people can contribute the most. Open models like GLM are already being made, and they're only getting better. They won't tell you about Tiananmen Square, though. But we'll get there. And I think of the model like the gas, and we still need a vehicle to get us where we want to go. So that's why I built Shakespeare. Shakespeare is a really open AI tool. It's a tool for building with AI that offers you Stallman's 4 freedoms. With Shakespeare, you can build complex web applications with a single prompt. Notably, you can build fully working Nostr clients. It's open source, runs on your device, and you have the freedom to configure it any way that you wish. Shakespeare is a name that I pulled out of the ether. It came out of the public consciousness. The most common AI format right now is written like a play. You have system, the voice of God, user, you, and assistant, the robot. In this format, the AI is actually not the assistant. The AI is a hidden inner voice. The AI is auto-completing the assistant, and maybe next it will be auto-completing you. There's also a saying that if you put 1,000 monkeys on typewriters, eventually one of them will produce Shakespeare. But I think our odds are better because people have already been producing hundreds of novel and interesting things with Shakespeare. Here are just a few, and you can do it too. Shakespeare works because I've poured my years of experience as a Nostr developer into AI context files, giving it just enough information that it needs to succeed without overly prescribing any particular user experience. One thing we did struggle with, though, was design. At first, it was producing boring, bland designs until I found this gem that I copied from another context file, and now a dramatic reading. Critical design standards create breathtaking, immersive designs that feel like bespoke masterpieces rivaling the polish of Apple, Stripe, or luxury brands. Designs must be production-ready, fully featured with no placeholders unless explicitly requested, ensuring every element serves a functional and aesthetic purpose. Avoid generic or templated aesthetics at all costs. Every design must have a unique, brand-specific visual signature that feels custom-crafted. Headers must be dynamic, immersive, and storytelling-driven, using layered visuals, motion, and symbolic elements to reflect the brand's identity. It must never use simple icon and text combos. Incorporate purposeful, lightweight animations for scroll reveals, micro-interactions, e.g. hover-click transitions, and section transitions to create a sense of delight and fluidity. This is the power that simple text prompts can play into building with AI. I have noticed that there is a bias, though. Shakespeare is a groundbreaking piece of technology. You will get results often better or similar to Lovable, a company valued at $5 billion. Shakespeare is faster. It works better. It scales infinitely for free. And you have complete control. But is it enough? When people fail at using Lovable or Replit, they blame themselves. But when they fail at using Shakespeare, they blame Shakespeare. Who am I? Hillary Clinton? Vincent van Gogh? Do y'all want freedom? Yes. Raise your hand if you want freedom. All right. Now let me show you how. Shakespeare runs in your browser entirely on your device. No download is required, but it works offline. It is a PWA. It uses isomorphic Git, a complete reimplementation of Git in JavaScript, allowing you to push and pull code directly from your browser. It stores files in your browser with IndexedDB. It connects directly to remote AI servers or local models. Projects written in TypeScript with React get bundled with ESBuild Wasm entirely in the browser using a custom build system that I created. Previews are rendered using iframes with postmessage. There is no server component at all. Shakespeare scales infinitely. Lovable doesn't need $5 billion. Every aspect of this thing is configurable. You can choose any AI provider, any Git host. You can buy credits with Bitcoin. You can deploy directly to Netlify, Cloudflare, our very own Shakespeare deploy, or even to Blossom gateways, all straight from the Shakespeare UI. You can even reconfigure the system prompt, add MCP servers, and much more. Where all of these other products fail, Shakespeare fixes everything. There are zero compromises. Check out realllyopen.ai to learn more about this chart here in which we stacked up Shakespeare against other AI tools. Stallman believed that even if you weren't a programmer, you could have a friend to edit the code for you. AI completes Stallman's vision, allowing anyone to do it themselves. You can use Shakespeare to build new AI tools. You can use Shakespeare to edit Shakespeare. One person did. This is After Hours, a fork of Shakespeare that was built in Shakespeare. What other AI web builder enables users to edit the entire platform within the platform? The AI bubble is ready to pop, and I'm here to pop it. You don't need billions of dollars to build AI platforms. And I'm here to say that it's actually not that hard, and that you can do it too. If you'd like to get started with Shakespeare, scan this QR code for $10 in free Shakespeare AI credits. And please, after lunch, join us for Chad's workshop, where he's going to walk you through building an app with Shakespeare. Thank you very much.
That was a probably our most poetic talk yet. Thank you, Alex. Do we have any questions for Alex on here?
I just tried to pay for it with Lightning, but why do you guys have a 10% processing fee for Lightning transactions?
So Shakespeare AI goes through Open Router, and so they charge a 5.5% fee. The other 5% is basically just like collateral. But I mean, you can use Shakespeare with any AI provider. You don't have to use it with Shakespeare AI. You can plug in Ollama. You can plug in Open Router directly. It's just a service that we provide to make Shakespeare easier for users who want to get started.
I have a question.
Sure.
Do you have a favorite OpenAI model?
GLM. And GLM 4.6 is extremely powerful. It's a Chinese model. And it's extremely important that people are building these things. Unfortunately, it takes about $1 million just in graphics card hardware in order to get started with even running something like that. So if anybody here has $1 million and they want to contribute to OpenAI models, I would love to work with you on setting up, a server rack or data center, and let's go. First thing I would do is probably train it to take some of the censorship out of it that the government of China has so willingly put in. But yeah, GLM.
That's just 10 Bitcoin, right? Yeah.
It's good at coding.
Cool. Are there any other questions? Village? Awesome. Oh.
Hi.
Hello.
I was wondering about software licenses. So how does, say, Shakespeare ensure that license terms are not being broken when code is generated?
That's sort of a bigger question about AI models and copyright. I'm not really sure how to answer that question, although I will say that the sites that by default it builds are based on the MKStack template, which is in the public domain.
Oh.
We've got another question over here.
Yeah, what is the angle with Nosta, like as opposed to just the general website building thing?
So when I was first learning about this AI tech, my wife was building Bookster with Lovable, and it was a frustrating experience because the model just wasn't able to do Noster very well. And so one of the main things that sort of pushed me in this direction of building this was because I wanted to be able to do that, like to be able to one-shot any Nostr application, like build a site like Twitter, build a site like Vine, build a site like Instagram, and for it to just work. And so MKStack is the template that Shakespeare uses. That you can actually use this with any other AI tool. You can use it with Claude Code if you want to, if you hate freedom and you want to use closed source technology, you can. You can use it with Goose, and it has this big context file in it. And it has some templating already available to sort of hook up to relays and to make all that stuff work. And so when you say build a site like Instagram, then it's going to just work on the first try. And that's something I was really interested in being able to succeed to do. And there's also an opportunity. Shakespeare has configurable templates as well for providing different types of context. We're also building skills to enable you to pull in context data of like, what if I want to add Nostr to an existing website? So it can do that as well. And yeah, there's a big opportunity for figuring out how to just produce these context files. I mean, I think that's kind of a big, next step of this challenge of I want to build a Bitcoin wallet, but it doesn't work perfectly well. Well, all that's missing is context. And once we have this context that can be reproducible, we can copy it around to other people, they can load the context in to their tool, then they can build a Bitcoin wallet effortlessly. And Bitcoin wallet is one it's actually pretty good at, but Nostr is one it struggled. I'm sure there are other areas where if it doesn't work the first time, it's just missing some context, and it's missing you to go in and figure out, why it didn't have the information and to provide that context for others in the future.
Thanks.
Yep.
Any other questions? Awesome. Round of applause again for Alex. Thank you. And that concludes our morning programming at day one. I think the sandwiches arrived. We'll be back at 1 o'clock sharp. Thank you. Welcome back to day one, main stage of Bitcoin++ Sovereignty Edition here in Taipei, Taiwan. Today is December 15th, and it is 1 p.m. local time. I'm Nifty Nye. I'm here to introduce the Portal project. They're building a sovereign identity protocol. And with us today is Alos Falini, also known for creating the BDK wallet development kit. And he's been working on Portal for a number of years now, along with John Galt, who's going to be helping out with the workshop. I think, unfortunately, due to the Wi-Fi being not amazing, most of this is just follow along and catch up on the GitHub later. But I'm very excited to have Alos here talking about what Portal is working on. So please, warm welcome to Alos. Thank you.
Thank you. All right, hi everyone. My name is Alos. I'm CEO and co-founder of Portal. John there is my co-founder. We have an hour, so we have, I would say, plenty of time. I'm going to give kind of a brief introduction first to what Portal is, what we're trying to build. And then we're going to leave, I don't know, like 20, 30 minutes for showing how to get started with Portal, in case anybody wants to try it out. I don't know if we're going to be able to actually do it right now. So the plan is just to kind of show you resources, GitHub links, the TypeScript library, this kind of stuff. John is here to help if you want to download the app and try it out. Feel free to bother him if you have any questions. So I'm going to start briefly, actually, with our story. So some of you may know us from the Portal hardware wallet. So that's what we started with a couple years ago when we launched the company. So we actually started building an hardware wallet with the idea of building a mobile-first hardware wallet. We wanted to build like a device that can keep a key secure and lets you use this key with a mobile device, so with an Android or an iOS device. We built that, and then we realized, first of all, building an hardware wallet is tough. It's a very tough market. There's also competition, like a very kind of saturated market, so it's very tough to enter as a new small startup. And also, we actually realized we could do so much more with just a private key. So people just focus, obviously coming from the Bitcoin world, people just focus on storing Bitcoin with a private key, and that's like a perfectly valid use case. But there's a lot more you can do, and you can do with it. And so this is why we started building Portal, the app, which is more on the identity side, we like to say. So the core mission of Portal is to give people full control over their digital life. So it fits really well with the theme of this conference, which is sovereignty. And conceptually, the idea is, just like with Bitcoin, you can be your own bank if you have your own private key. We want to do the same for many, many other use cases that people encounter pretty much every day in their daily life. So nowadays, we have digital products everywhere. So we use smartphones, laptops, pretty much every day. We interact with electronic services as well. So maybe we go to the supermarket and we don't speak with the cashier, but we use like a digital system to check out. And so we want to improve the way people deal with this kind of interaction in their daily life. And this all ties back into identity, because when you interact, you as a human interact with any kind of digital online service or physical service, you usually have to kind of identify yourself. For example, you need to log into a service to get access to your private information, private cloud, private whatever. Also tied to your identity is, we call them tokens, but it means many, many things. So tokens is anything that can be tokenized and then can be transferred between people, usually is tied to some identity at some point. So for example, you can buy like a subway ticket, and that subway ticket is yours, and then you can go and spend it to access the subway, so like spending it at the turnstile of the subway. Or maybe you can transfer it to your friend, so you can buy like a couple, and then give one to your friend so you can both enter the subway at the same time. So those are also somehow tied to identity. And then lastly, payments. Obviously, most of human to business interaction is somehow connected to payments. So when I interact with a business, there's always kind of the assumption that I'm going to be paying for a service, paying for some kind of good in return. So again, like buying a ticket, buying credits from a cloud provider, etc. And this all kind of ties into you as a human, as a user. And we want to empower people to own their identity by basically owning their private key. So I'm going to start getting into kind of the details of what those three things mean, starting with identities. So basically, within our app, within the portal app, you can hold your Nostr key. So your Nostr key is your identity. This is what identifies you. It's like a pseudonymous identifier. So it's not tied to your name, to your real name. So you can have also as many identities as you want. You can throw them away and start fresh whenever you want. And we support, recently with an update we just released, we support NIF46, which is the banker protocol. So basically, you can have your Nostr key in the portal app, and you can keep posting on any kind of social media client that can connect to a Nostr banker service. So you don't have to have separate identities. You can use the same identity both for accessing stuff and for posting on social media. And the most basic use case you can do with identity is logging into supported websites. So I'll get into the details later, but we provide a Portal SDK that you can use to integrate Portal in your system. So if you're running a business, you can basically authenticate your customers using Portal, so they don't have to sign up with email and passwords. And we all hate passwords. It's always like, it's not complicated enough, then it's too long, then it's too short, then you need to change it every once in a while, then they get leaked. So with Portal, you basically skip all that. You just log in straight with your identity. And what we're working on right now is kind of a two-tier system. So basically what we want to do is we want to let people have one master key, which is their actual identity, and then they can act with secondary keys on behalf of their master key. So basically, they can keep the most important key, they can keep it offline or on an hardware device. And then they act every day through their smartphone using one of the secondary keys, which has like a shorter window, like a shorter expiration window. So maybe once a year, you need to refresh your secondary key. If it gets compromised, you can revoke it, kind of like GPG. So this is what we're working on right now to improve even more on the problem of identity, which we think right now, at least in the Nostr world, that's probably the biggest issue. The fact that you have one key and it needs to be auth every time, all the time. We want to kind of split it into one master key and then several auth kind of temporary keys. In terms of payments, what happens with Portal, so if, again, you as a business, if you use the Portal SDK, what's happening with Portal is just transferring a Lightning invoice from the user to the merchant. So it's not really it's not BTC Pay server, let's say. It's not like a full-blown payment gateway, but it helps transferring the invoice over. And so this basically skips the step of pulling out your phone, scanning a QR code, opening the wallet. You kind of skip all that because from a merchant perspective, you just request a payment from the user. They get a notification in the app that says, do you want to pay $5 to this business? Yes or no? Just press yes. So we kind of integrate everything together and provide a better user experience. And we can also do recurring payments. So basically, what it means is within Portal, you can pre-authorize future payments. So you can say, I'm OK allowing this business, which is identified by a public key. So I'm OK allowing this public key to charge me like $5 every month. And this is all validated like client-side within the app. Every month, the business is going to ping me, send me an invoice for $5. And my app is going to locally verify that, first of all, yes, the amount matches. I haven't paid this business yet this month. I'm going to verify all that. And if everything checks out, then the app is going to automatically pay. So you can also use Portal for this kind of recurring payments. Right now, if you want to use, this is kind of optional. So you can also completely skip the payment side. So you can not have a wallet within the app. But if you want to have a wallet, right now, we only support Nostr Wallet Connect. So basically, you need to have kind of an external wallet, and you link it within the app. But we just merged, like literally yesterday, a PR to have an actual embedded wallet. So with the next release, what we're going to be offering to users is, if you're an advanced user, you can link an external wallet. If you are like a newbie that you know what you're doing, we just create a wallet for you. And this is all built on the Breeze SDK, in case you're familiar with that. So that's also going to be coming probably beginning of next year, so in January. And finally, on tokens. Tokens is a very broad concept, but basically what it boils down to is Portal is also a Cashew wallet, so we use Cashew for eCash tokens. And we don't use them as monetary tokens. So what we actually have in mind is we want to use tokens to tokenize stuff. And I mean, it's not going to be us tokenizing stuff. It's going to be businesses tokenizing whatever they offer using Cashew tokens. So going back to the example I was making before, if you are the public transportation authority, you can tokenize subway tickets, for example. And Cashew works really well for this. Because it's not a blockchain, it's not inefficient like a blockchain. You don't have transaction fees, you don't have blocks and stuff. Basically, with Cashew, you can print, the mint can print as many tokens as they want. And this is maybe not great for monetary use cases, but this is perfectly fine for businesses issuing services to their customers. So by definition, a business can print as many vouchers, discounts, tokens or subway tickets as they want, because by definition they are the entity kind of issuing those services. So right now we are focusing mostly on tickets. So the plan is to use it for events, especially like Bitcoin events, obviously because we come from the Bitcoin world. So you can buy a ticket, you get it in the app, and then when you show up at the event, you just spend it to get access to the event. But eventually, we also want to support, we want to kind of broaden the use case for tokens and also use it for like loyalty points, credits, vouchers. And also another thing we're exploring right now is using those Cashew tokens, which are eCash tokens, for age verification. So this ties back to the idea of identity. So you as a user with your identity, if you want to access a service that's age restricted, you can verify that you are, let's say, above 18, and you get issued eCash tokens that you can later spend at the business to get access, for example, to an age-restricted like gambling website or whatever. And this is, I don't know about Asia, so maybe you're luckier than us, but for us in Europe, let's say the European Communist Party is imposing a lot of this age verification stuff on businesses and on users. So we think it's very important to provide privacy tools and kind of sovereign tools even for these kind of use cases, which obviously we don't like, but we kind of have to deal with it. So if we can improve the privacy, the people's privacy, we're going to do so. So again, tokens are like very broad concept. You can do lots of stuff. So how does it work? So basically, Portal is a protocol that exchanges messages via Nostr relays, and this is done to basically make it, let's say, decentralized, or at least it's done so that we are not a single point of failure. So if we go down as Portal company, if our service go down, or if we close down entirely, the whole thing can keep working because there's going to be other Nostr relays that can still exchange messages. So that's, we think, very, very important. And it's basically what it means is kind of a peer-to-peer protocol. So it's merchants talking directly to their customers. We don't see anything. We don't have any control on that. So we just provide the tools. So we provide the app, which is the client, the customer clients, let's say, the app that the customer uses. And we provide an SDK for businesses so that they can talk to their clients and, again, like request a login, request a payment, all this kind of stuff. And another really cool thing is that it also works in person via NFC. So basically, the same messages that are exchanged via Nostr relays, they can also be exchanged via NFC. So when you show up, going back to the example I was making before, you can like show up to the subway, you tap your phone, and you are transferring the subway ticket over NFC. So eventually, and we're kind of working on that too, eventually you will be able to do this completely offline. It's just kind of a local transaction between you and the business. And you can use it to, again, like pay, kind of like Apple Pay, Tap to Pay, or spending tokens, or identifying yourself. So like you show up at your hotel, which you booked through your identity. You tap your phone, which has your identity, and you just get access to it. So there's, again, lots of things that you can do. So how do you get started? We kind of provide all the tools for businesses to build on Portal. The core Portal is a Rust library with what we call bindings, even though they're not really bindings. So technically speaking, it's basically separate pieces of code that talk via WebSockets. And this is done basically to make it much faster to deploy new languages. So the core of the code is in Rust, and it's basically like a WebSocket server, and you can connect to it, and it's basically RPC. So you can make remote procedure calls. You can call functions into the Rust code from, right now we have TypeScript and Kotlin as the two kind of supported languages. But it's very easy for us and for external contributors to show up and add support for new languages because it's just JSON over WebSockets. So that's why we decided to go with this architecture. And also, if you want to play with it, if you actually want to build something with it, we recently partnered with the Sovereign Engineering Court, which is a Noster program that's happening in Madeira pretty regularly. So I'm sure some of you are familiar with it. So the next one is going to be in March. It's going to be like 3 weeks starting at the beginning of March. And it's going to be the SEC 06. And the whole topic is going to be identity. And I think it's identity and signers. So basically, the whole idea is we're going to go there, spend 3 weeks there, hacking on those stuff. So building on Portal. And we're basically welcoming people to bring their ideas and hack together using Portal and other tools as well. So this is the end of my brief presentation. This is a QR code if you want to download the app. Although I have to say, we accidentally just pushed a broken build on the App Store. So if you download the app, it's not going to work. But I'll fix it later, like literally after this talk. So maybe if you're on iOS, just wait a few hours or tomorrow. But yeah, this is the end of the introduction. I'm going to start showing like all the tools, all the GitHub links and stuff you need if you want to get started with it. And maybe I should take, actually, if there are any questions, maybe I should take questions right now, and then I'll move into the more kind of technical side of it. So does anybody have any questions about this, about everything we talked about? Right? No questions. So I'll get into kind of all the links, all the GitHub stuff. Feel free to, oh, sorry, there's a question down there. Yeah.
Hi. I was wondering, like, what happens if my keys leak? How do I recover from that failure?
Yeah. So right now we only support you having the main key in the app. So if the main key is leaked, you're screwed. There's no way to recover from that. But what we're actually building towards is this two-tier system that I was mentioning. So then the idea is going to be you have a main key, which ideally should be on an hardware device, on an offline device. And then you export from the hardware device a secondary key. And this is what you keep in your smartphone. So if the secondary key is leaked, you can revoke it using the main key. So let's say your smartphone is stolen, for example, or lost. You can buy a new smartphone. You get your hardware device, and you say, I lost this key, I want to revoke it. And so you're basically going to sign a message that says, this key is not valid anymore. Now this new secondary key is valid. And also, secondary keys are going to expire automatically after, I don't know, like a year or two. So this is going to be more or less the range we're thinking about. So even if you don't do anything, after a while, those old keys are going to expire, and you can always make new ones. And this is kind of an improvement we want to propose for Noster as an ecosystem, because this is missing right now. So right now you can only do delegated keys, but that's a bit more convoluted. So what we have in mind is we're building like a very short kind of proof system where that I can basically attach to any anything I do. So whenever I make like a post on Nostr, I'm going to make it from a separate key, and I'm going to attach a proof that says I'm actually this other key. So it's very easy to validate. So this is what we're building, and it's going to be a few more months, I think, before that's ready. Cool. Are there any other questions? OK, so I'm going to start showing you some links. I don't think we don't really have enough time, and also with the Wi-Fi situation, we cannot really like get into actually building code. So I'm just going to show you the tools, just give you a bit of an introduction in case you want to start building stuff with Portal. And obviously, I'm going to be around, so if you have any questions, you can come to me. Also, John is not really technical, so John is more for helping with the app, and I'm more here for technical questions about the code and stuff like that. So I'm going to start by showing you our GitHub. This is our organization. It's Portal Technologies, Inc. And under our GitHub, you can find pretty much anything. So starting from the app is in React Native, in case you want to check it out and hack on the app. And then we have the lib, which is the main Rust logic that is later exposed both to the app and to businesses via the SDK. So first step, I would say, if you want to get started on Portal, you go to getportal.cc/docs. Actually, I should make a QR out of this. So this is the docs, like the main docs, well, for everything pretty much. I'm just going to keep it over here. And if you go through the docs, it kind of explains what is Nostr, what is Lightning Network, quick start. Then we get into kind of the more technical stuff. So we, as I was mentioning before, we have this Rust logic, which is a WebSocket server. So you can either take it from GitHub, and it's in the lib repo. So you can take it from the lib repo under this directory. It's called REST because it used to be kind of a REST API, and then it just migrated into WebSockets. So either you take it from here and you compile it yourself, or you can just take it from Docker. So here in the docs, there's all the commands to download the Docker image, and this is going to be your, we call it kind of the SDK daemon. So this is the thing that you need to leave running, and that actually interacts with Nostr, interacts with with the clients of the Portal protocol. And there's examples of like Docker compose files and things like that. And you can also build it from source. Then once you're done with that, you can basically start integrating Portal into your own code. So I was mentioning right now we support a TypeScript SDK and a Kotlin SDK. The TypeScript SDK is published on NPM as Portal-SDK. And the Kotlin SDK is on GitHub. I'm not familiar with Kotlin, but I think there's a way, if you know Kotlin, you probably know what I mean. There's a way to take a dependency directly from GitHub, like Gitpack or something like that. I don't know. I haven't done any of this. But you can also find the, yeah, it's this thing, Gitpack. You can also find the Kotlin SDK on GitHub. And it's the same interface. So it's kind of a mirror a little bit. And so what you would do then in your code is you construct an instance of this Portal SDK by giving it the URL of the server. You can also have multiple instances kind of share the same server. You need to connect and authenticate. This is just like a static token that you configure in the Docker. You configure it through the Docker environment variable, so then you can connect to it from TypeScript. And then once you're done, you can start interacting with Portal clients. So usually everything starts from this key and shake URL. So this is a URL that a merchant would generate and encode in a QR code so that the user can scan the QR code and kind of trigger all the interaction. And I can probably show you from the demo website. So this is, if it loads, this is our demo website. So this is where we it's kind of a playground that we use to test stuff. So everything starts from this QR code, which we call the key and shake QR code. If you are on the same device, you also have the option of pressing a button. So if I open this from my smartphone, I can just press the button, log in with Portal. Otherwise, I can scan the QR remotely. Let's try doing it live. And this is, it's called the key and shake URL because it's done to kind of make an handshake between a smartphone and the business. So after this step, both sides of the transaction will know each other's public keys. So after this handshake is done, the business will know my public key from my app, and my app will know the business's public key. So after that, we don't need to scan QR codes anymore. We can just talk directly by sending each other Noster messages on the same public key. So I'm going to try scanning it from here, see if it works. So now I've approved the login from the app. And well, this is, again, kind of a debug dashboard, but it shows what Portal can do. So you can, after you're kind of handshaken, you can request payments, you can issue or request tokens, you can manage subscriptions, stuff like that. So all of these things can be done from the SDK API. So if you look at the API here, you have, for example, authenticate key. This is a call that you can use to send a smartphone an authentication request. So this is going to show like a pop-up that says, do you want to log in into this, yes or no? You can request recurring payments or single payments. You can do a bunch of stuff, and I would encourage you, if you want to get started with this, just check out the docs that are on NPM, where all of these methods are documented. And again, it's basically just wrapping Noster messages back and forth. So when you're going to make one of these calls, it's going to send a message on the other side, and then the other side is going to reply with like yes or no, or it's going to pay the invoice or anything like that, and it's going to send back the response. So what else? Yeah, so and also here in the docs online, you can find examples for all of these things. So you can see the authentication flow, what it looks like. Usually starts from generating an authentication URL, the user opens the URL, et cetera, and it shows it's like full of examples showing you how to do any of that. If you want to do the token thing, you will have to run your own cashew mint. So this is also documented under here, so running a custom mint. So we have a fork of CDK with very minimal modifications. We just add public endpoints that add extra metadata to the units supported by the mint. I was mentioning before, we are mostly focusing on events right now. So in your mint configuration, you can specify the name of a unit and then the kind of this unit, which right now can only be event. And so then you can set like a location, a date for the event. You can also set, I don't think it's shown here, you can also set like a custom picture that's going to show up in the app. So you can configure all that and you can run your own mint. And then through the Portal SDK, you interact with the mint to print tokens. So whenever, let's say, a user completes the checkout, you make a call to the mint, you print a token and send it to the user. And so then it's going to show up in the ticket section in the app. Well, in terms of relay management, we run our own relay, which is relay.getportal.cc, but you can also use any custom relays. We generally suggest at least keeping ours, so you can use multiple relays at the same time. Our relay basically only lets Portal messages go through, so you cannot use it to post on social media. You cannot send posts through that. but we have very relaxed spam filters. So you can spam as much as you want, as long as it's portal messages through our relay. And this generally helps with reliability, because other relays, if you do lots of activity, tend to rate limit you. So yeah, we recommend at least keeping ours as well. Yeah, so I think this is pretty much all for this kind of brief introduction. Again, we were kind of planning on letting you guys hack on this, but I don't think we can get it done. Also, probably we don't have much time for that. So yeah, if you have any questions, if you have anything you would like to know about this, if you want to try it out, yeah, please let us know. Yeah, I think this is it. Thank you. Yeah, we have plenty of time. Last round of questions. Otherwise, I'm happy to leave the stage.
I think it would be cool to show the payments and the cash on the demo, since
Maybe, yeah, we have time. Maybe I can plug in my phone and show it. Let's do this. I know there's a way to show. So there should be a way from QuickTime to show my iPhone's screen. But I don't remember how. Does anybody know how to do this? Do you know how to show an iPhone screen from QuickTime? I'm sure I've done it once. I don't remember how it's done. Because it's... Okay, thank you.
These instructions here. So, file, new movie recording.
Yeah, this is what I was doing. I don't know why it's not. So it's file, new movie recording.
And then
oh.
Instead of that, yeah.
Yeah, okay.
iPhone?
Yeah. Yeah, thank you so much. Is it not? Okay. Yeah, looks like it's working. So this is the main kind of home page of the app. So this is what you're going to see after you complete the onboarding. The onboarding is literally just like any other wallet. You just generate your own key. Or you can also import an NSEC or a BIP39 key if you already have one. So during the onboarding, it's going to ask you, do you want to generate a new key, import a key? Do you want to link a wallet? So in this case, I already have a wallet connected via Nostr Wallet Connect. And after, at the end of it, you basically end up in this page. And you are going to get an NIP05, so like a username automatically assigned to you, which you can also change. So you can also configure your profile. And you can see I have logged in before, so the username is the same that you have here. So I'm going to maybe start over. Just show the login first. So when you're logging in somewhere, you scan the QR code. And you get this kind of pop-up request where you can say yes or no. So this is kind of the philosophy for the app, to make it very simple, and it's just yes or no. I think now it's timed out, so probably going to have to redo it. No, it still worked. So this is, again, the first step in which both the app and the service exchange the public key. And then after that, you can send requests for example, let's say I want to request, I don't know, 50 sats. And I just get a prompt in the app that says, do you want to pay 50 sats, yes or no? So again, let's say yes. Let's see if it works. Yeah. So we also support, this is kind of a new thing in the latest release, so it's still a bit glitchy, but we also support notifications. So in theory, we are able to wake up the app remotely if it's shut down. So if you have your phone locked, you're going to get a notification that says, do you want to approve this payment, yes or no? I don't have them here because this is like a debug build, so they don't work here. But this is kind of a new feature we just released, which means you can also we can also process recurring payments in background without having the user to unlock the phone and approve and stuff like that. So it's all pretty much automatic. In terms of Cashew, here in the bottom side, there's a ticket section. So these are the tickets that I have in my wallet. The orange thing is actually like a real ticket for a real conference. This is the biggest Italian Bitcoin conference, and they are issuing tickets through Portal. So this is going to be my ticket when I show up at the conference. And then this is kind of a test ticket that we use internally. So I can also show you, let's say, I can mint a token. So here I just, from the dashboard here, I just printed a new token and sent it to the app, which usually takes a second. OK, yeah. It took a while, I guess, with the connection. So my app received the ticket and completed all the steps with the Cashew Mint to import the ticket. So now I actually have 2 of those. Before I only had 1. And then there's also like the opposite side, which is you can request the ticket back. So you can request a token and basically to burn it, like when a user shows up at the conference. I think, again, it's very slow with the network. But yeah, so you get a request that says, do you want to send this token to this entity, yes or no? If I say yes, I'm going to send the ticket back to the business, and the business can claim it back and burn it. Subscriptions work pretty much the same. I can request, let's say, 10 sats every hour. When I send this kind of request in the app, I can approve future payments. So I can say, yes, I'm fine with 10 sats every hour, approve. This is going to show up in this separate section, which is this subscriptions sections. And from this point on, the service is going to ping me every hour with an invoice for 10 sats. Locally, my phone will make sure everything is all right. And if it is, it's just going to pay it automatically without the user having to interact at all. What else? What else should we show? Is there anything else?
Fiat payments, like fiat-denominated
payments. Yes. So it's not obviously real fiat payments, but we do have currency conversion. So you can say, I want to request €1 payment. And this shows up as €1, and underneath, this is your local currency. So I have my app set to sats as my local currency, so I get an automatic conversion that shows the amount in my local currency as well, which also works for fiat to fiat. So if you have like a USD app, then it also converts to that other fiat pair. Yeah, I think this is all. Again, if you want to get started, come to the SEC. It's going to be super cool in Madeira. We're going to be hacking and building for 3 weeks. So if you want to play with Portal, you're going to see us there. Also, again, we're going to be here for the duration of the conference. So for anything, please bother us. Please come speak to us, me and John. Thank you.
That was a great talk. Quick question. So there's a hackathon that's happening tomorrow. If anyone's interested on building it for that, are you guys going to be around, or do you have any tips or tricks for anything people should look at overnight if they wanted to build on it?
So yes, we're going to be around. We don't have a track specifically for Portal, but we're just going to be around. So if you want to play with it, please do. I wouldn't say tips or tricks. So just start from the docs, pretty much. This is the entry point. This is also very kind of early stage tech. So it's still being built right now, literally. So the docs may not be super up to date. So if you find any issues, this is why we're here, so we can help you out and explain everything. So yeah, I would say just start from the docs. The SDK itself is very, very easy. It's designed to abstract away all the complexity. So you're just calling kind of high-level function, just authenticate this user, request a payment from this user. So you don't have to deal with all the technical details. You don't have to deal with the Noster encryption and stuff. You just stay at the high level. So I would say it's very easy to integrate, even in existing projects, as maybe alongside email and password, you can add Portal as authentication and stuff like that. So yeah, absolutely. If you want to build with Portal, just come speak to us.
The protocol is very general purposed, so basically you can do almost everything. That we abstract so at a high level that you can do basically everything.
Yeah, it's designed to give kind of as a tool for businesses and merchants to build their own business. So we just provide high-level primitives like authentication, payments, ticketing, and then you can build your own stuff with it, your own business or project with it. Right, cool. Thank you so much.
Bitcoin Plus is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin sovereignty. Run your own node, hold your own key. Bitcoin is freedom, peer-to-peer, on-chain and off. Meet the sovereign builders of tomorrow.
Welcome back to Bitcoin Plus Plus afternoon of day one. Very excited to be joined today with Chad Curtis from Soapbox, who's going to be showing us all how to build a live app using Shakespeare. You'll need your laptop or a telephone for this. So maybe pull those out. And without much further ado, please give a warm welcome to Chad Curtis. Thanks.
Thank you. Thank you. Yes, welcome, and thank you all for taking your time to join us today. This is Building of Shakespeare, and I will be your host. I am Chad Curtis, the head of Vibe Ops at Soapbox. So very, very on topic, I know. So before we get started, I know there have been some dubious network issues today. Please raise your hands, team members of Soapbox, both in front and the very back. Take a look around, anyone who may not be employed by this company. If you have any issues at any time, particularly with networking or using Shakespeare or anything in between, raise your hand and one of our team members will be over to assist you. Now, I'm sure there's a good question here bubbling. Well, maybe not so much after Mr. Gleason's speech a couple hours ago for those who may have attended it, but still, what's Shakespeare? So, to go forth, one moment here. Oh, there we go. Haha. So Shakespeare is a completely in-browser vibe coding application with a particular penchant towards Noster clients. But you can build many things with it. You can build sites like Twitter. If you say, build me a site like Twitter, or even just the word Twitter in some cases, it'll go through, build everything, and output something that is very likely in that form. And I might be retreading a couple of technical topics here. But yeah, it is completely offline. If you lose connection to the server hosting this static code, the PWA will continue to work. If you have it on your phone, you can open up Shakespeare. And if you have an Olama server in your house, you can point to that. Soapbox, whether it's here tomorrow, next year, or 10 years from now, Shakespeare will persist on your device forevermore. And I think that is a very novel thing. So as far as things that can be produced in Shakespeare, I'll go with a few examples that I have personally created, just to give a quick heads up or run through. For example one, a geocaching website, decentralized geocaching. Whoever may not be familiar with the idea of it, is a hobby where you go forth in the world and hide little boxes out into the wilderness, out in the metros, any nook and cranny that one may find. In this case, I have made treasures, a way to do this over the Nostr protocol in a very lovely decentralized manner. And let's see. So you may not be one to go outdoors. That is OK. I am also somewhat inclined in that way. For people such as that, I've made a tarot reader to go forth and describe your destiny for the day, or even the week if you so prefer. And in this case, a Nostr integration is you can share your fateful outcome to your kind one feed, the equivalent of a basically a tweet feed. And for those who are even more reclusive, in my own selfish development desire here, I've created a website to host and share Magic the Gathering decks for any who may play. If not, I suggest getting in. It's a great game, especially if you have a printer at home. You can get all the cards you want and then some. But the point here is you can develop pretty much anything of Shakespeare. Vine, short-form videos, Tamagotchis, social media of all sorts, decentralized chats, podcasting, music, even abstract concepts that may not be easily represented, but you may be wanting to push the boundaries of what the Nostr protocol may support. If you can dream it, if you can think it, then you can most certainly build it in this case. Let's see. Moving forward, yeah, showing here, we have a myriad of apps, like maybe, well, probably at least 20 or so, maybe up to 100. But the point is, many examples exist out there built by Soapbox and people in the community. They are all templates, all seeds sprouted out into this world that can be grown on their own or remixed by anyone in this audience, anyone watching from home, anywhere, at any time. You may notice in this screenshot here, but yes, each of these items has an Edit with Shakespeare button, which means if you see, for instance, say, treasures and you want a different version of this with a different set of features, you can click that button, clone in the project, and do anything you desire with it. If you want dark mode, if you want, well, there is dark mode, but if you want darker mode, perhaps, or pink mode, you could do that. Or if you want to do something of geocaches in space, the world is your oyster or tofu for our vegan-minded friends in the audience. Now, retreading once more slightly, but in the spirit of sovereignty, freedom, FOSS, and self-ownership, Shakespeare is a platform of total user choice. You have the choice of your AI provider or model. You can plug into our built-in proxy, Shakespeare AI. You can use OpenRouter. You can use the Olama server in your house, or you can use whatever may come in the future here. Maybe it'll be running from your phone or directly in the future. You can use any payment method. You can use USD via Stripe, Bitcoin Lightning. You can use any Git host, be it GitHub, GitLab, NGit, which is Nostr Git, or anything that may support cloning repositories. And finally, you have full choice of where you may deploy these sites, be it our own native Shakespeare deploy on shakespeare.wtf, Netlify, Vercel, Blossom servers, anything, and probably many, many more in the future. We dug so deeply into this concept, we put together metrics on realllyopen.ai that you can go through and view later. But TLDR, Shakespeare comes out on top for a lot of things in terms of user freedom. So, as far as what Shakespeare excels at, front-end websites, your portfolio for who I am, if you want to be hired, or just show your work to the community, about sites for a concept, specific applications, particularly Nostr applications. I'll take a quick pause here to say, how many of you in the audience are familiar with Nostr? Raise your hand if so. All right, that's a good number. Excellent. For those that have not, is an acronym for notes and other stuff transmitted by relays, which essentially, the TLDR of that would be these self-signed, or sorry, author-signed like JSON events that go into stores and can be retrieved back and forth. But ultimately, you have a portable identity where this data can be represented anywhere, anyhow. in any manner you desire. And it's great in Shakespeare to build these concepts out for your communities, applications, ideas, what have you. And leaning in more into the themes of this conference here, you can build sites with Bitcoin, Lightning, or Cashew integrations. Now, as far as where to get started, there are multiple avenues to achieve success here. As mentioned before, everything that we've built, everything that exists as a template, all of these are editable items on the front page of Shakespeare. You can go and start with any template and click Edit with Shakespeare and build on top of that, or just completely remix it into your own vision. You can import a compatible project via the Edit with Shakespeare button, a GitHub clone link, zip file, and potentially more in the future if such options are supported. Or simply, if you wish to go clean and just want to go with a full new idea, you can start with a prompt and interact with the agent however you may desire. Now, as far as how to start with option 3 here, there are many options there as well. You can say, build me a site like Twitter, for instance. If the model is good enough, just as a reminder, in case if you're using Opus, you could say Twitter, and it will probably be intelligent enough to go through and build something out. You can say, build a Cashew wallet with an integrated social feed with post tagged hashtag Cashew. You can say, build a site for my nonprofit animal rescue. And these, all sorts of concepts, I'll go through an example here shortly, but really anything you can think of that can be manifested as a web application or some kind of store of data, it likely can be done via Shakespeare. As far as more nuanced prompting skills, it is very good to sometimes give the AI direct or more focused directions as far as like where you wish to take it. You could say, generate a good hero image. So for instance, for treasures, I was doing this yesterday, saying, generate me like a map of the world with all sorts of lines and compasses and whatnot, and replace like the SVG at the top of the site. Excellent for that. You can give it resources to say, if users are curious about X, Y, or Z, point them to these URLs. You can potentially even pull information if it is understood or public knowledge. You can give it a mock-up. You can actually take a screenshot of a Twitter-like site or an application you really love and say, build me that. I want something that looks like exactly like this. Or you could even hire a designer who makes a nicer mock-up than whatever you have made and paste their design in and say, make it look like what they made. Or if you're not entirely sure yet, you can just simply say, don't build anything yet. Let's just talk. Tell me, what do you think about this? What ideas? How do you want to go forth? So speaking of starting here, I hope many of you have opened your phones or laptops, anything that may be able to reach a network of some sort. For here is a QR code. If you did not scan it earlier, here it is once more. It will give you 10 USD of Shakespeare credits, applicable for this workshop here. If you are feeling more dexterous, you have, of course, typed the URL at the bottom of the screen there. That is faucet.shakespeare.diy /3GGAACQK. And I'll leave that on the screen just for a minute here so people can get caught up. So if you have not used Shakespeare before, what you should see is basically a prompt or a modal that says, congratulations, if you got your gift card. It'll, I believe, have a toss to agree to just for getting through all the rigmarole of setup. And after that, you should be able to get to the UI. But I'm going to walk through this with you live here. Whoop. Oh ho. One moment. Let me change my display mode. And then we will work through together. OK, we'll do mirror mode. All righty. Let's see. Yes, keep this configuration. Most excellent. So yes, you should see this. And I'll go forth and agree to redeem now. Excellent. So hopefully you haven't been too hasty, because if you click this text box, you'll at least be prompted first to choose a model here. I would suggest for this session Claude Sonnet 4.5. It is a nice, stable, intelligent model to work with. Let's see. And once you have that selected, then you can begin from any prompts that you may think of. I'll work along right with you here to start with. Let's see. So I thought about this actually often during my trip over here, and just what would be a spontaneous thing to build on the spot that might be interesting. It's almost Christmas time, and there's a concept of the Secret Santa style event. And I was thinking, you know, someone actually built a Secret Santa application, so kudos to them. But I wanted to do something even more extreme, like a hidden Santa. I have one person, one budget, one shot to make this work. So box person will be over to you shortly. Let's see. So, build me a site with a slot machine like UI that determines a gift to give to someone that I am following. The items on the slot machine should be a person from my follow list, a gift from a random generated list, and a budget for the gift in USD, at least for now. And we will see what happens there. And it'll begin the process here. Give it one moment. You know what? Yes. So you may get a pop-up here to allow Shakespeare to store data in persistent storage. You can decline, but I will hit allow because that will give us a bit more redundancy here if for any reason this laptop suddenly shuts off. But may luck be on our side for the remainder of this presentation. So you can see Claude Sonnet 4 has gotten to work here, saying, I'll build you a fun gift slot machine that pulls from your Nostr follow list. Let me start by exploring the project structure and create the slot machine interface. So it's looking through, saying, here's what the project looks like. Here are some files. It's basically, so it's taking what is called the MK stack template, which is just a base of components that it can use like Lego blocks to plug in and remix and create different applications. But it essentially has the core of everything that you could build for most common like use cases. Although this one's probably stretching a little bit here. And it's going through, it's being very intelligent, it's using our tooling to say, okay, I want to look at how Nostr handles the contact list, which is a kind3 event, the follow list. It's feeling pretty confident on here. It's writing, it looks like a hook to utilize the follow list. All right, let's see, it's building out the slot machine component. And as it does build, it will repeatedly re-render here. We're in the early stages where it's purely just trying to figure out how to organize. But let's see. Oh, now it's going to create the main page of the slot machine display. All right. Let's see. Now, this may be a bit daring, but let's say, I would not recommend this for anyone but me right now, but just to give you a different example while that's building, Shakespeare can also make very captivating arguments for you via websites with image generation. Now, I'm sure there's a whole myriad of controversial topics out there, but for today, I will pick one that's particularly dastardly, the topic of pineapple on food. And I figure, let's do this. Make me a site with images that argues that pineapple should be on all food in existence. And we'll see. I know it's a very, very bold thing to propose here, but if anyone can make a convincing argument, I believe Claude Sonnet might be able to. So we're going to let that start. It's using, in this case, it knows that this is most certainly not a Nostr-related website, so it's using what's called LoveStack, which is basically the same set of components but without any of the Nostr integration. Okay, let's see what we have here. It says it has something. I'm going to build really quick just to see what we got out of this. And while it's doing that, let's review. Okay, that's very ambitious. Let me log in really quick here. Let's see. Downloads. Okay, interesting. Oh, so our default here, my good friend Patrick, well, I haven't spun it yet, but this is actually a great suggestion because he loves to read. And maybe I will follow this and get him a book that's $25 to $50. But let's see who our lucky contestant is today. Oh, and also just to show here, it says that there might be a console error. Oh, that is nothing to relate to functionality, but if you do hit any kind of issues, our assistant here, Quilly, will go forth and give you a heads up of what's going on, and you can click this link to go through and fix anything if it is blocking your productivity or flow in developing things. But let's give our first spin. All right. Wow, Patrick gets an even more expensive book. Okay. Good luck on him. And Derek Ross will also be reading as well. Let's see. You know, I suspect there might be something here. Let me interrogate our friend here and say, why is this machine so rigged to give everyone books? It might just be luck. But while it's doing that, let me go ahead and demonstrate. So with Shakespeare, of course, you have this preview screen here to go and see how your work is going. When you're ready to share with your friends or anyone around you, you can click deploy. If this is your first time using Shakespeare, you will get a screen that says, essentially, choose your deployment platform, because this is a very user choice, freedom-oriented project, so we don't want to really lock you into anything quite yet here. You can click Add for Shakespeare Deploy, and it will pop up, voila. So while this is going, and it claims, let's see, what does it say here? You're right, books are the second item in the list. We'll get back to that momentarily. Let's see. So let's deploy what we have here. We'll pick Shakespeare Deploy. It'll give you what's called a stub here, which will be a subdomain on shakespeare.wtf. This can be anything you want, but it'll default to your project name. And we'll click Deploy. All right, give it a moment. Give it an extra couple of moments here. Let's see. There we go. All right, and now we have our site. So of course, let me disable my dark reader extension so we can get all these beautiful colors. Oh, I actually could log in with the Soapbox Signer extension developed by Mr. Shantaram in the audience. I highly suggest it for anyone who may have any Nostr needs and require login to any Nostr application. All right, let's see. And I'm curious if it actually had managed to fix this. Let's give it another whirl here. I don't know. Patrick is getting too many books this Christmas. I'm going to have to interrogate further. Let's see. Actually, I'm probably being mean to it. I did not actually rebuild the project. I've been tabbing in and out of everything here. Let's see. So what did it initially find? Books are the second item on the list. They appear at the top frequently. Oh dear, is this actually a case of terrible luck? I would not be surprised. So we have 40 different gifts. Math random, more diverse options. Okay, interesting, interesting. Let's see. You know, I'm starting to think this thing might be rigged. That's okay. Let's go into a different educational topic here about pineapples. And let's see. Actually, I'll deploy this one once more. So just a reminder, this is the very controversial topic of pineapple on everything. We'll see how this bodes, or what arguments our AI has made of its generated images. I will actually scroll back up here, because if you request image generation, oh yes, because I cleared out, that's okay. We'll see them on the site here. So let me disable the dark reader so we get full colors. Oh, beautiful, look at that. So let's see. It's presenting an argument of, well, see the evidence. Why should pineapples go on everything? The science is clear. It's not just delicious. It's scientifically proven to enhance virtually any dish. I don't know about that, but it has 100% natural enzymes. Let's see. Bromelain breaks down proteins, tenderizing, meat, tisk, I'm a vegan. So we'll have to discard that evidence from the court. It does have a perfect flavor balance at 4.0 pH. So great meal for anyone who may be curious in such matters. Great vitamin C. And it can be caramelized and given a umami enhancement. So there we go. That's actually some pretty compelling evidence. Goodness. So it can go well on apparently pizza, burgers, tacos, curry, fried rice, and ice cream. I would generally agree for maybe ice cream. Okay? The Pineapple Manifesto, oh goodness gracious. We hold these truths to be self-evident that pineapple is not merely a fruit, but a culinary catalyst capable of elevating any dish from ordinary to extraordinary. That the fear of pineapple on pizza was merely first battle in a war against flavor innovation, a war that we have decisively won. That the combination of sweet and savory is not controversial, but scientifically optimal, supported by enzymatic action, flavor chemistry, and the universal truth that complexity delights the palate. From this day forward, we declare pineapple belongs on everything. And I suppose you can click to accept this truth, although I don't know. I think I might actually reject that one. But still, a great tool for making arguments on anything against anyone, for or against yourself. If we have a future in which pineapple is on everything because of this, I do apologize in advance. Let's see. So, what else may we do here? So I've gone through and given examples on deploying. I'll actually go to my other browser here, many, many projects, to give a different type of example. So let's see, this treasures application. I believe it'll create a new version of this, but I'm going to the front page. I'm clicking Edit with Shakespeare. And on this import screen, if you happen to have used Shakespeare frequently, you'll actually get a list of projects that have been pushed up to Nostr Git. I'll go into that momentarily here once we get this cloned. Okay, so we have treasures 1. Let's see. I'll call this space treasures. Okay, and we'll say, please, let me correct the spelling there, please make this a site that is focused on hiding treasures in space, because we have very grand ambitions to go forth. And this is more so just buying some time here while people build. But I will say, if anyone has anything that they've built and managed to deploy, don't hesitate to raise your hand. I am happy to give you a 1 to 2 minute demo. Aha, there we go. Yes, yeah. Let's give our gentleman a mic here, and if I can get a URL, then we will be in business.
Add? Okay.
That's it. It's done. And now you go back to the app.
Mm-hmm. Here?
Uh-huh. And then deploy from the, yeah.
Here?
Yep. Deploy.
Deploy.
Yeah. Just.
Shakespeare deploy?
Yep.
Okay, excellent. And can he see it, or?
Oh, yes. Let's see.
It's cypherpunk -quotes -bot .shakespeare.wtf.
Shakespeare.wtf. Let's see. All right. Give it one moment here. All right, and
yeah. So my idea was I wanted to create a bot on Nostr that would just automatically post quotes from random cypherpunks, maybe every, I don't know, day, every twice a day or something like that. So I had it run this prompt, and it collected a bunch of quotes from cypherpunks there. And it even set up like GitHub Actions, and at this point, it gave me instructions on how I can set this up so it can automatically post. It says I need to publish this repo on GitHub, generate a Nostr key pair, and then enable the workflow in the Actions tab. So I haven't gotten around to doing that, but I'm probably going to do that next, and then hopefully there's just an npub that everyone can follow, and you can wake up to some wisdom from the cypherpunks.
Amazing. Yes, give a round of applause. Yeah. Yeah, you're into some advanced territory there. That was awesome. Oh, wow. All right. Has anyone else deployed the project yet, or maybe curious to share what they're working on? All right. Give this gentleman a mic, and we'll get these stub URL.
All right. My URL is lunch today.
All right. Lunch today, like so?
Yeah, that's it.
All right. Let's open her up. Okay, lunch today. Oh, all right.
So basically, this like a meal. Like we sometimes we don't know what to eat in office pretty often, so we can just have the area, location, and the budget today. Then we can spend for today's meal.
Oh my goodness.
Yeah, and I think also there's my restaurants that for manually we can enter some restaurant we really like. Yeah, and currently I think the data from the here is like a markup data here. So I'm trying to figure out how can I add some API interacts later on.
Yes, this is another awesome concept and a great point there on the APIs of any kind of like public information. I have found the best Shakespeare sites are ones that can pull from public data and utilize that in ways very similar to this. But even if it does not have real locations, I might be using this later to decide where to go. Oh, goodness. Yeah, this is great, great. Man, good job on both of you. Yeah, round of applause. All right. Anyone up next? Let's see. Oh.
Got one.
Oh.
DAB. That's it.
DAB? All right. Let's see what you've got here. The dab. Ah, yes, a very familiar move.
Yeah, this is just an example utilizing Shakespeare's image generation feature just to argue that for dab supremacy as the best dance move.
Oh my goodness.
Yeah, it generated all of those images. Actually, I think Claude generating images from GPT image 1 is like the greatest possible combination. GPT can't generate, can't write image prompts as well as Claude can. It's incredible.
That is true. Yeah, I didn't need much convincing on this one. I am convinced.
It even made,
Let's see. Oh yeah.
It even made at the very top, it made like a sparkling stars animation. I thought that was really cool.
Yeah, yeah.
When you scroll a little bit, yeah, see that?
That is very cool. I feel like I need to steal this one for later. That is an interesting effect. Very nice. All right. I'll showcase one functionality really quick. If anyone has anything else after that, please don't hesitate to raise your hand and we will share. Yes. So let's see. It looks like it's still working on this. Wow, it really made space treasures. I was curious where it'd take this. It's made it very purple, very space-like. I mean, I can explore the cosmos, although I don't know if there's any OpenStreetMaps data for this. But that's okay. Let's see. All right. I'm going to say this is good enough. Please, let me correct that. Please commit my changes. Normally when it's done through a workflow, it will automatically make it commit for you. But in this case, I am just cutting it short and saying, this is great, you've made it purple. I love it. So we'll let the tool call make the commit. All right. Give it a moment here. Excellent. And it'll usually give an after-work summary on what things look like and how things are, what it's done and why it thinks they are great. In this case, it has turned geocaching into a space treasure hunting experience. I'm sure this will be very popular in the 3000s. Let's see. Now, as far as getting this change merged in, I'll open up this repository here. So just to go through, you can click the triple dots. There are actually multiple options here. You can reset your chat if you've gotten stuck. You can roll back if you feel like the AI has gone too far and you need to go back to a previous change it's committed. You can deploy it. You can even clone your project and view details, which have the option to export and delete. But in this case, I simply want to make a pull request against whoever this clown is who made treasures. Let's see. So, checking repository permissions. Of course you are. Please merge my cool change. And if this was anything but treasures, I would say probably come up with a more professional title here, but that's okay. I've seen such PRs or merge requests in the past. We'll say please, and then I will say create pull request. All right. Oh, it's because of GitLab. That is my problem, because I have cloned it from a very tainted source here. Let's go into the magic of Noster Git. Let's say Noster, goodness, hub.io. All right. And there are many Noster Git implementations. This is just one such implementation created by Gleason. Let's see. Aha. We're going to take this jumble fork here. Well, actually, let me go down a little bit more. Aha, the AI bubble site. I'll take that. I'll import it. There we go. All right, give it a second. And let's see, we'll be, you know what? I'll make a simple change just to showcase this. Agents. We'll make that. There we go. A very significant change in this project. All right. You're not logged into. Let's log in here. Actually, oh, I see, because it has a token there. That's okay. All right. Format, GitHub, GitLab. That is okay. Oh, because I've not actually made changes here. Okay, we'll go into the terminal and make this like really, really official. Which also another feature, if you go in, you can view files, edit them manually. You can go into a terminal and use the isomorphic git CLI. So I can say git status, git checkout be new thing. All right, and git add status. All right, my cool change. And there we are. Now let's see if that is enough of a mutation here to create a pull request. Oh, perhaps, perhaps not. That's okay though. Let's see. Yes, we'll do that once more and see here. And support remote URL format. Oh my, we may. Oh, let me push. There we go. Our final key to the puzzle potentially. One more branches are not updated. Oh, I did instead of Noster Git. Tisk tisk. Yes. There we go. Soapbox support is so helpful. They help everyone around them, including the presenters. Okay. Let's clone it officially using the Noster URI. This is actually a great example here. Oh, ignore that. So Noster over Git is a very cool concept. There are repository announcement events, and then there are basically these graph servers that store your code in a very decentralized manner. And when you are interacting with it, you should use the Noster // URI for getting and cloning. If you're blanking out like me and you use HTTPS, you might run into bad times. Let's see. So we'll edit once more and do that and save. All right, and then git checkout b new thing, git commit m new thing. Oh, whoops, git add, and then da-da. Okay, and let's see, is that good enough? Repository announcement, oh yes. Let me, oh, this is where our fun networking issues come in, because now it needs a repo announcement event. Well, alas, I might take this as our fun example of a demo thing going wacky for the day, but if all things work well, you should be able to publish a patch. And if it had the repository announcement, i.e. the networks are all being super stable and working with us, then it would go forth into a place like Noster Hub and open up a pull request for my very meager change here. But that's okay. You have plenty of time to experiment and edit projects at home and do what have you. So just walking through just different functionality here. Does anyone else have anything they'd like to demo or showcase based on like what they've worked on? Aha, give this gentleman a mic. Digital-temple. Thank you. WTF.
Yeah, so in Taiwan, people will make ghost offerings by burning some paper artifact, but here we have the digital version of that where you can buy using Lightning. And after you sign into a Nostr account, you can buy artifacts that you can then burn.
Very cool. Whoa. I really like the design of this one. Very nice and warm and glowy. Let's see. That is a novel idea. Please give a round of applause to this gentleman. This is a beautiful concept. Oh, but I don't have a wallet connected to this browser. But it is pretty cool. So,
yeah, I tested with just a quick, I burned the cheapest thing, the sacred incense, and I actually don't know where it went. It'll be interesting to see. I need to go check on the blockchain to see where my offering went to the ghosts.
Yes. Let's see. Interesting. Very interesting.
But yeah, unless you connect an account and fund it, I don't think it'll let you burn anything.
Yep. That is smart. I like that. Well, very cool. All right. Let's see here. Does anyone have anything else they'd like to showcase or demo? If not, I can go back to giving some more examples here. Aha! Excellent. Thank you very much, Shantaram.
How do I showcase it? Do I tell you the URL? Okay, it's BTC pp-lunch-buddy.
Lunch dash.
Yeah.
P as in Paul?
P as in Paul, yeah.
You got it.
No dash between the BTC and the...
You got it as well. All right.
Lunchbuddy.shakespeare.wtf.
Excellent. All right.
Dun, dun, dun.
All right, walk us through here.
Okay, this was a one-shot prompt. I made an app so that you can find a lunch buddy at Bitcoin++. You have to log in with Nostr, but you can post where you're going to get lunch, and then people can RSVP. Looks like we already have 2 upcoming lunch invitations. One is hacking lunch at Bitcoin++ tomorrow. It looks like the date is wrong. It should be for tomorrow, not Monday.
Oops. This might be a my laptop issue. Fret not.
Okay, yeah, at 10 p.m. Okay, that'll be tomorrow at noon here. It looks like Xfrog, one of our AV directors, is doing Steak in the Mall tomorrow. So if you want to find a lunch buddy, check out BTC.
There you go.
PP Lunch Buddy.
Yeah, excellent. Cool. Yeah, massive applause for this. That is really cool. Let's see. Hacking lunch as well. Yes, yeah, so for those, obviously there's a hackathon. Hopefully this is brewing some good ideas here. And if not, well, hopefully lunch and Shakespeare will inspire further. Let's see. Many cool things. Thank you all for presenting your examples thus far. Let's see. I'm going to see if there's anything else that might be interesting to showcase. But just before I go into that, is there anything anyone else would like to show? Because I love the things everyone's been making. I'd much rather see your creations than mine here. All right. Going once, going twice. OK, no worries at all. Let's see. So I will go more into the template examples here. Yes. Oh, excellent. Perfect. Yes. Oh, yes.
You can go ahead and open it. Okay, so this is Villager that I made entirely in Shakespeare. Not right now, but last week. This was inspired by some stuff going on in the US and just the need to be able to help our neighbors out, especially with food and some other urgent needs that were coming up. And I wanted an alternative to things like Nextdoor and Facebook groups where people are organizing. So I made this 100% in Shakespeare. It's all on Nostr, and you can connect with people nearby you pseudonymously if you want, or you can put in your real name and connect that to your Npub. It uses Web of Trust to help people feel comfortable interacting with anonymous Npubs. And people can post their needs and their offers. So you can say, I need food for my baby, and people can offer and say, I have extra infant formula. So this is just a way for neighbors to help neighbors and to kind of build that in-person village. It also connects with Bitcoin, with Lightning. And so you can zap people, for example, if they say, I need money for groceries, you could just zap them and give them that money directly so they could go buy groceries. Or if you see someone providing an offer that you think is really like important, they're saying, oh, I'm providing free food for people, then you can just go ahead and zap them as a thank you for the fact that they're providing that offer for their community. There's also things like community events that are all around based on location. There's resources, and you can also direct message people depending on how the internet is doing. But yeah, so this is one that I made that I was pretty excited about.
Excellent. Yes, applause. Yeah, this is such a cool idea. I like the idea or mission statement of something like a next-door application, which is neighbor-to-neighbor communication, but is a very centralized platform. So things like this, I think, are amazing and are going to be great for building a decentralized future. Yeah, this is awesome. Love the design here. Very, very nice color palette. Excellent. All right. Let's see. So walking through. So we've gone through. Actually, I'll showcase. What if I take something too far, just to show really quick what a rollback might look like. Let me go back to my browser here. OK, nothing too crazy. Let's see. I'll go back to this site and say, this argument is not strong enough. We really want to be building a tower to the moon made of pineapple. I need you to generate images and really convince me of this great idea. All right. And we'll see how far this goes. But while that's running there, this is some actual work on treasures here where I was trying to generate some SVGs. Or rather, a replacement for the SVG of all sorts of cool globe imagery. On here, very similar on the, maybe not pineapples, but for at least geocaching. I wanted to see, hey, could it make a compelling argument for why the decentralized solution is pretty good in comparison? It made some valid arguments about paywalls and data theft and made some very beautiful imagery to support this claim. But point is like you can do just about anything of Shakespeare here. As you can see, we have community assistant apps, cypherpunk quotes, a meal roulette, arguments for the dab, commentary on AI bubbles, and they're popping here, digital temple offerings that you can burn, and a good way to make friends over lunch. But you can build anything. You can build the app of the future. You can build a pamphlet to convince people of whatever thing you may think will make a great change in the world. But this is a tool that allows you to actually make these dreams manifest, which I think is amazing here. Let's see. So while that's going through, does anyone else have any examples they'd like to showcase or any new things? If you're building a second app, for instance, feel free to raise your hand again. I don't mind that at all. But I want to make sure everyone gets a chance to show off everything they've made. Let's see. Personal portfolio. I'm going to build something based on this, or not, because terrible, terrible networking today. That's okay, though. We're persisting through. All right. Let's see. Space treasures. How do we want to take this in a different direction?
Hey, Chad.
Yes, sir.
Another thing that might be good is to walk through settings.
Oh, walk through the settings, of course. Actually, is a perfect point here. So yes, Shakespeare is highly customizable. You can set your theme to your system default, which mine is dark in this case. I'll make it light for the sake of viewability from this giant screen. You can set any language, be it English, Portuguese, I believe Mandarin here, and all sorts of things. Of course, I'll go back to English, and you have opt out on sharing error reports when things blow up. Here's an extended view of the AI providers. As we said, you can use many options here, walking through the default Shakespeare AI. You can use OpenRouter. You can hook up Routster for someone in the audience here who may be talking about this at some point here. Let's see, you can add a custom provider. So if you have your Olama machine running on your laptop right now, you can hook in your endpoints. on localhost 11434/v1. I can't guarantee the results from this experiment, but it's something that is supported, and if you have $1 million of graphics cards, you may flourish yet. Oh, advanced, yes, good call there. Yes, so hidden under here is advanced. You can select your image generator. The way Shakespeare AI works is, even though it's using Claude, it's using GPT Image 1 to generate images driven by prompts that Claude has created. As Alex noted earlier, that's a beautiful combo. You can view and modify project templates. And by that, this is basically whatever you may want for MK Stack. This is NutStack, developed by one of our team members, Lynn, for creating cashew integrations. Very, very cool. And then going back once more to LoveStack, the nosterless, pure component-only template you can build from for making pineapple-related arguments. It supports MCP tools if there's anything that you may find useful there. There are plugins, although let's see. Now, I'm not sure if it'll, oh, it actually found it. So yes, there is the concept of skills, which are these augmentations of concepts that you can bring in. So let's say I need to build something very centric on Bitcoin. You can say, I want to pull in Bitcoin skills, developed also by Mr. Lemon. And excellent. It's been pulled in, so now it's a skill. And I can potentially say, build me a Bitcoin wallet, and it will be able to pull from this lexicon of interesting concepts that say, here's exactly how you do that. Let's see. This is a place to add plugins, and you can actually modify the core system prompt. So every time you are generating something with Shakespeare is going through and using this as the core initial prompt. You can change it whatever. You can modify it to simply say, hello. I would not probably do that, though, for the sake of productivity. But the point is that you have complete freedom here in every single aspect of this platform. This is, we saw this earlier. You can set up integrations with GitHub and GitLab. In my case, I have GitLab set up so I can push stuff directly to the main branch for some of the applications I've made. Let's see. And then I believe if you're using a gift card, it'll generate an ephemeral identity. But you'll see your Nostr blog in here. You'll see your relay configuration. Hopefully you have a good set. I think our default is good, but of course, Wi-Fi pending, that may be determined, else mean otherwise. You can say read or write for each relay. This, I believe, is a relay event list that is shared via, was it NIP65? But alas, if you have something list already, it'll probably pull it in and show it here. These are the Nostr Git servers. We have git.shakespeare.diy and relay.ngit.dev, which is maintained by Dan Conway Dev, the core proprietor of ngit, or at least for this part of it. Let's see, and then we have our deployment options. Of course, we're using Shakespeare deployed today, but you could use an Insight deployment, which is basically just deploying your static website to a Blossom server via a, I believe, pubkey URL. You can use Netlify, Vercel. You can deploy Cloudflare workers, to our example here for our Cypherpunk in the audience. You can use Dino deploy, and a custom provider that may support something else in the future. But plenty of options. I fully expect this list to grow with time. You have options for storage. You can export your entire profile, your entire Shakespeare existence as a zip file, and you can purge everything if you wish to reset everything from scratch. And there are a myriad of options here. You can open the terminals. You can set various things for where projects are stored, where Sentry errors are put to. You can disable, enable the showcase. You can even change the iframe preview URL. So when anything renders over here, it's going through thing.local-shakespeare.dev, which is a worker to render this. But if you have a different implementation in mind, you can absolutely control that. You can change the JavaScript CDN, so everything's running through an ESM build, which is pulling packages from esm.sh. You can change the favicons used for AI providers. You can change your proxy. You can even update or clear out or completely unregister the service worker related to this application. And finally, going through, you can modify the source code in many ways, mirrors, what have you, get updates via email, and verify that, yes, we do have an AGPL v3 license. But yes, many, many, many options and full user customizability, everything in your browser right here. Very, very cool stuff. Let's see. So, the Help Center right here? Yes, excellent point. So, outside of this workshop, if you need resources on how to develop with Shakespeare and need questions answered, we have plenty of tutorials and resources to go through. Many provided here by Soapbox members, such as MK in the back. Derek Ross, if you recognize his face. Shout out to you if you're watching at home, Mr. Ross. Let's see. And yeah, a good Q&A and many, many options to go through for choosing your models, setting up providers, using local models, deployment. Basically everything I've talked about in this talk and probably then some. AI debugging is probably my favorite thing because as fun as vibe coding may be, you may reach a point in your project where you need to figure out how to get out of a metaphorical hole that you've dug because you want to do a very, very complex feature set. But for most things, I would say smooth sailing. But the great part is resources are plenty here for anything that you may conceive or think of. Let's see. All right. So I know we're running a little close on time here. Does anyone have anything they want to demo or any final thoughts or questions? Oh, there we go. Oh, all right. Yes, hand the mic to Liz in the audience.
We're going to see if this works, because this would be social, and that means my computer needs to continue to stay online. This is an attempt to recreate Words with Friends on Noster. One of the two.
Yes, both are acceptable.
So if you log in as yourself, Chad, you should see, this works, you will see a challenge from me.
Oh.
I'm waiting for you. Let's go.
Let's see. Oh, goodness. A true opponent may be waiting. Although I think our real enemy here may be the networking. But...
yeah.
Oh.
There we go.
Whoa.
Let's play.
Holy moly. Very cool. Let's see. Yeah. Oh, my. Well, I've never been one to particularly excel at these games here, but let's see. Oh, it's your turn right now.
I think it may be my turn.
Yes.
Yeah.
All right. You're about to school me.
Well, I don't know about that. Let's see how we go here. Oh, I think I'm back offline again.
Oh, dear.
All right. We'll see how we go. What the heck? Okay, this is... I don't have good letters.
That's okay. You have excellent prompting skills.
All right. Let's see.
Wow.
I don't know. We may be out of luck on this one.
No worries. I am impressed with this Scrabble board down here. This is very cool.
All right. Let's see. Boom.
Oh.
6 points, baby.
Oh, boy. All right. Let's see. Oh, goodness. Oh, I see. That's okay. Okay. Here, let's do this. And I know I have a great deep lexicon here. We will put nut and see. Oh, I got 3 points. All right, I'm behind here, but yes. Goodness, this is very cool. Yeah, this is a great example. So if you're not looking to move the world quite, you just want to move your friends, make them games, and challenge them openly in public. You will make many friends, enemies, and advance the cause. But in this case, I am won over by this concept. This is, I am very mesmerized. Oh, okay. Let's see. Oh, dear. Now, let's see. This is the part where this is like an abbreviation. Will it take it? Oh, wow, it did. Okay. Wow. But yeah, very cool stuff. Yeah, one more round of applause. This is amazing. Yeah. All right. Well, we have a few minutes left here, so I'll go ahead and just close out. Thank you so much for your time today. I know it's been an hour-long workshop. We've had many interesting things shown up, and I've gabbed your ears off for a very, very long time here. But if nothing else, I hope you take away the idea that anything you can think of, you can build it. There are all these closed source, very proprietary AI solutions out here. I know there is a very dark timeline being projected to the future. It does not have to be that way. You can build the future right here, right now. Like the freedom is in your hands, and we are here to provide as many tools as possible to allow such emancipation. But if nothing else, thank you very much for your time. I deeply appreciate it, and that is all from me.
Bitcoin++ is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin. Bitcoin++ is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin sovereignty. Run your own node, hold your own key. Bitcoin is freedom, peer-to-peer, on-chain and off. Meet the sovereign builders of tomorrow.
How many of you have tried using Xpubs across multiple wallets? Okay, maybe it's just a few of us. I think Kevin here is going to tell us today about how not to reuse Xpubs across wallets. That's cool.
Like that, yeah.
Great. Okay. All right. Without much further ado, big welcome to Kevin. Thanks.
Thank you. So I'm going to talk about Xpubs. I'm going to talk about wallets. I'm going to talk about things that you might not be aware of when you are actually using your wallet. And it's basically, I was talking with Lloyd before, and it's basically a 20-minute rant about how things shouldn't have been done, but they have been done in a way that now that wallets are progressing, it's getting harder and harder to avoid users make mistake, basically. This is a discussion. It's not yet a full solution, although I think we made a pretty good progress on how things should be done. So there is a post on Delving Bitcoin that you can participate in about this. I will have the link at the end. And let's hop into it. So first of all, just a disclaimer here. I assume this is a technical conference. So I assume you basically know how HD wallets work, what an Xpub is, how wallets work, etc. Might be a bit technical otherwise. Well, I'm not going to be doing any code stuff, but I'm also not going to explain you the tiny details about derivation and things like that. So first of all, definitions. As you may know, especially if you work on wallets, everything is a wallet in Bitcoin, which is kind of horrible. So I'm going to talk about this definition. So a wallet, for me, is a set of UTXOs, a set of coins, that can basically be associated to each other with what we call a descriptor. So wallet is a bunch of UTXOs, right? Then a software wallet is not a wallet. It's a software that helps you manage these wallets, and you could have multiple wallets per software wallet, right? So maybe that's called, like, I don't know, a wallet manager, right? Then what people call a hardware wallet is not a wallet either. It's typically a signing device. Signing device has private keys, and it's signing transactions. I'm calling it a signing device here. Of course, you could have signing devices that are not hardware wallets in a traditional sense. It could be on your phone, could be on your computer. But here, I'm not talking about hotkeys. So I'm talking about, physical signing device that are security focused. Okay, so some facts. Users, so you guys, me, we typically have multiple Bitcoin wallets. We don't have just one, especially over a lifetime. You might have multiple ones at the same time. You might have one that's like what you call a cold storage, and then you have one for spending. You might have one on the, I don't know, a peer-to-peer exchange. You might have one on a mixing software, etc., etc. So users have multiple wallets. Also, users tend to change their wallets over time. So if you've been in Bitcoin for a long time, you might have had a wallet before HD wallets. You might have had a wallet before Segwit, etc., etc. And so typically when you move on, you have a new wallet. You don't have to generate a new mnemonic every single time you do a new wallet. And that's actually a bad practice to generate a new mnemonic every time, because then you have so many backups to take care of. You might misplace one of them. You might do mistakes with them. So it's perfectly okay to reuse the same mnemonic across wallets. But what's not okay is reusing the Xpub, so a specific derivation of that key. People do not write down their derivation path. They do not currently back up their descriptors, and they should. So users have been told over time that just keeping your mnemonic, your 12 or 24 words, is enough to recover your money. Horrible practice. This is just not enough to recover your money. Sometimes it is when it's a single sig, a basic one. But as soon as you start doing more interesting stuff, you will lose money if you don't track more information than just your mnemonic. The mnemonic is just a private key, doesn't contain any information about derivation path, doesn't contain any information about time locks, multisig, etc., etc. So that's one thing. And then there is another one that I will cover a little bit later, which is about the account number. That's also a thing in HD wallets. And no user that I know of is writing down which account number they used already. So I'll cover that. And also, now that more and more people are using multisig and organizations are starting to store some Bitcoin across multiple people, it's getting extremely hard to do rotation of wallets in a multisig. One of the reasons is just because every time you need to have everyone be present again to generate a new wallet. And again, that's not very practical. So here is basically, the problems we have. As I already covered, managing multiple mnemonics is much harder than having one properly secured. So I'm a huge fan of reusing the same mnemonic, reusing the same signing device across different wallets. I'm not saying you should just use one for every single wallet you have, because you might be participating in one for your company, one for yourself, etc. You can reuse the same. You don't have to. I'm not saying you need to have only one, but at least don't start making a new mnemonic for every single wallet you have. It's not practical. So why am I talking about this Xpub thing? Why is it bad? It's basically bad for privacy. So when you reuse, or when your wallet, it's not you as a choice reusing your Xpub typically, it's just your wallet generating the same one. When you have the same Xpub in multiple wallets, it basically will generate the same public keys at the same index. So the first few addresses, even if they are different addresses because they are different wallets, will have the same public keys. And of course, when you start spending from this wallet, an observer would be able to see, oh, this is using the exact same public key on different UTXOs. So they are connected to the same user, at least to the same signer, but basically the same user. And so it's really bad for privacy. So if you start reusing a signing device for your organization and another one for your personal wallet, or one for your personal wallet and then another one for your cold storage, you might actually be linking these two without knowing, just because public keys are reused. So terrible for privacy. Why is it a problem? In my opinion, the whole way we're dealing with derivation paths today is horrible, and that dates back to basically BIP 43. Where we started having a field called the purpose in the derivation path. And so at the time, it was kind of assumed users were having single sig wallets. So you would basically have a mnemonic, and then you have different kind of upgrades in Bitcoin that can be defined in different BIPs. And so by just using the BIP number as one of the paths of the derivation index, you would be generating different Xpub, because if you change any of these derivation, you would have a completely different Xpub with the same mnemonic. So let's say if you had a ledger device from before Segwit, and you use the same ledger device on a Segwit wallet, you would have a completely different Xpub being used. So that's great for the user, but then what if the user start reusing this key across different wallets? So of course, if it's single sig, it would be the same wallet anyway, at least up to recently. But if you start doing multi-sig, now you have a problem. Because in multi-sig, same thing, there is a BIP for it. I think it's BIP 48, I'm not sure actually. So one of the BIP is defining like behavior in multi-sig, but you could totally have the same signing device across multiple multi-sig. I could use it for my personal multi-sig at home, and then I can use it for my organization multi-sig that I have with other people. And if I'm not careful, I'm going to use the same Xpub, or my wallet is going to use, my software wallet is going to use the same Xpub without me knowing. And I will basically link these two wallets together, which is terrible. So that's what I mean by we can have multiple wallets with the same purpose. Purpose is the name of this field. It's not necessarily unique. So yeah, the BIP is bad in that perspective. Another thing that was then added, because of course it was an issue, BIP 44, the one just after that, is like, oh, but now we can have multiple accounts for the same purpose of the same mnemonic. So now, again, we're still in this behavior of like, okay, the user is only going to keep their mnemonic, but now they have a number that's called the account number that they are supposed to remember somehow. And we still didn't tell them, hey, you need to write this account number on your backup, because otherwise you don't remember how many times you use this key. So if today you use a wallet, like a software wallet, like I don't know, a Sparrow or whatever, it will ask you which account number you want to use for that key. And that's what it means. It's basically asking you how many times did you already use this key in a wallet. Probably you have no idea. I mean, maybe it's your first or your second, that's great. But if you've been using Bitcoin for a long time, you might have no idea how many accounts you're supposed to be incrementing to, right? So terrible again. How are we supposed to keep track of this account number? So horrible UX. Users that are not extremely technical have no clue about this. So it's completely useless from a UX perspective. We can't use that. So basically, what do we want? We want to make sure users, normal users, cannot reuse Xpub, because it's bad for privacy, right? So how do we make that? So we want to make sure that they never reuse Xpubs. We want to make sure it works across software. So you want to be able, of course, to import your backup from Sparrow to Nunchuck to whatever without breaking things. I'm also talking about vendors here, because you might be using a service with your wallet, so it might connect to whatever service where it tracks your wallet or your account on a server somewhere. So let's say you use a Blockstream Green or even Nunchuck. You have a cosigner that can be there, and so it's tracking you somehow. So how do we make sure using these different services can work with whatever solution we will have? Also, it should not be able to conflict with existing wallets the user already have with this key. So if I've been using my wallet with account number 1, 2, 3, 4, I don't want my solution to use the same numbers, otherwise it's defeating the purpose. And we need it to be practical for non-technical users and safe, as in they shouldn't be able to lose their coins because they can't figure out their derivation path. That brings the question of one of the issues about these BIPs that I was talking about before. So currently, all these derivation paths to generate an Xpub are typically hardened. What it means is that you need to have access to the signing device to be able to generate the Xpub. That's kind of cool when it's a single sig. You can assume it's OK. But if it's in a multi-sig, that means that every time you need a new wallet, you need to have everyone, again, in a room to be able to plug in their signing device. You might be like, oh yeah, this is a weird example. But nowadays, we're starting to have more advanced wallet that really makes sense of this. So multi-sig, as I just explained, maybe I'm in a business, 2 of 3 multi-sig, I lose my key and my backup. I just want to replace it with a new one, want to create a new wallet. Now, I cannot just create a new wallet and tell the other guys, oh, your backups are fine, we're going to use the same, but I just created new ones for me, so here is a new descriptor. I can't do that because I cannot generate a new Xpub for them without accessing their device. So they would need to also participate, plug in their device, remember their account number, give me a different Xpub for every one of them. Absolutely impractical. You also have now some wallets that are using absolute time locks. So If you know Liana, that's a wallet we work on. We don't use absolute time lock right now, but if you know a Keeper or Nunchuck currently, or even Anchor Watch, they are using absolute time locks in their setup. An absolute time lock expires at a specific point in time. So you know that at this point in time, you will have to rotate your wallet to a new time lock. You cannot push it in the same backup, right? So if you want to use these kind of services, why would you have to, again, have access to your key to generate the new wallet? Your software should be able to just generate a new one with a new time lock and just find a way to not reuse your Xpub. So again, we don't really have a standard for that. So every one of these wallets is typically doing unhardened derivation, but there is no standard. Not great at all. And then there is another use case again, typically the use case of Liana, where I might have my normal key that can spend all the time. I have a backup that is super secure somewhere that is not easy to access, and I don't need to access it. If I need to change my key for one reason or another, maybe I want to go from single sig to multi-sig or whatever, and I want to keep the same recovery key without having to go in the forest and get my device again and restart my whole thing. I just know the Xpub of that wallet, but I don't want to reuse it because it's bad. How can I generate a new Xpub of that key without me going to access it, right? And so these are very practical problems today that we wallet developers have to look into if we don't want users to fuck up their privacy. There is one problem though, well, I didn't really explain that, but yeah, so TLDR, hardened, not possible to fix most of my problems here. If it's hardened, I need to access the signing device. I don't want that. This is not practical. So we need to use unhardened derivation if we want to fix that problem. But if we use unhardened derivation, now we're bringing new privacy issues, which are basically that if we have co-signers, as in different people in the setup, right? Me plus my colleagues, if it's my business setup, and then I also use the same key on my personal setup, if it's unhardened and too simple to guess, my colleagues could basically figure out what other wallets I have, and so they could figure out how much money I have at home, which is also terrible. So unhardened is just harder to fix the privacy issue. I'm also talking about services here. So as I mentioned before, co-signing services, potentially, Nunchuck Keeper, Anchor Watch, Casa, whatever. These services need to know the descriptor of the wallet. So again, we don't really want to have them know be able to know my other potential wallets that I'm using with this key, right? So we need to be careful about that. There is 3 different approaches we can use. The most obvious one is to keep a state somewhere. That means tracking this account number, but not asking the user to know about it. Just have something keeping this state. It can also be completely random, because we can put pretty much whatever we want in each of these derivations. So it could be a random number, or it could be deterministic. I'm going to go through each of them. So keeping the state, the main issue is really where do we want to keep a state, and how do we want to keep it. The most obvious solution is basically on your signing device. So as the Frost presentation before was explaining, for the nonce reuse, to avoid the nonce reuse, they basically track that on the device itself. And that's cool. But I don't like this idea for derivation here, or for the account number, because you can assume a user will lose their signing device or break it, but they still have the backup. But when they import the backup to the new device doesn't have the state. So it will again reuse Xpubs. So a state on the device, not a good idea. A state on a server somewhere, you basically trust a specific service. You could imagine having it on Noster, but Noster has no guarantee of availability. You could put it on the blockchain somehow. Maybe there is solutions there, but it's none of them is great. Random number seems like the perfect thing, because if you use something like this, where you have pretty, you can have as many as you want, but this is already a pretty tough number to brute force. that's pretty great. Like, it fixed most of our problems. Just generate a random derivation every time. I'm assuming, of course, the user keep their descriptor, so they don't have to keep more information about that. This is not going to be brute forced by one service or another. And I can just do that in an unhardened derivation. So if I rotate in a multisig, I can actually generate a different random number for my, my cosigners and just send them the descriptors afterwards. The problem here is that it completely breaks the signing device user experience. So when you generate this thing, you are going to have to verify on the signing device what your key is, etc. And this is more like, this is basically more garbage that we are showing to the user. And we know that the users already are overwhelmed with all the information they don't understand on their hardware. So if we show them a random number like this, they're not going to verify, they're just going to press next. And that was already used in the past to do some ransom attacks on hardware wallets. So currently, hardware wallets do not even let you display such a derivation path, because they know malware have been doing that in the past, where your signing device has the key of your wallet, but if you don't have a backup of this derivation, you will never be able to find it. So you had to pay a ransom to the malware to have actually access to your own money that is still controlled by your key. So it was not a theft attack, it was a ransom attack. So this kind of stuff would work, but it just doesn't work from a UX perspective. Deterministic might be better. So in this example, I picked the, basically, date, right? So you have the date of today. You have the time. It's not, well, I'm pretty good. You have the time of right now. So let's say 16:04 and 45 seconds. The user can understand that, and you could display it in a proper way on the signing device as well, right? You could make them separate, etc., so the user know they're actually checking the date of today. And of course, every time they reuse their signing device, it would be a different date. So you have no reuse of Xpub here. One of the issues here is that you can brute force that. So back to the problem where one of the signing partner I have or one of the services I'm using could potentially try a lot of dates and time and try to find my other wallets. So we could kind of fix that by adding, again, more digits. Could be random, could be going down to milliseconds, whatever. But yeah, it's just not perfect UX again. But I think this is like the best option we have right now. So at least in all this kind of research we're doing, it looks like this is the best way of making sure users never reuse an account number, they never reuse an Xpub. You can generate, you can basically generate new keys, new Xpubs for other keys without having access to the actual private key or the signing device. So you could do rotation for multisig, yeah, even for your own without having access to your own key. So that's like pretty cool. I don't know if it's clear, but let's say something I could do here is that we could set up a multisig wallet right now with one of the keys I don't have with me. It's like somewhere in a different country. But because I have access to one of my other wallets, like not the private key, just the wallet itself, the software, I could just derive a new Xpub, give it to you. You have no idea about my other wallets, and I know I'm part of your setup. So this would be pretty practical. So yeah, issue is that it's brute forceable, and yeah, so I'm pretty much done, but I want to cover another part, of course, of this talk, which is that we need this information somewhere. It needs to be stored somewhere. But there is also other information we need the user to have in newer wallets. So typically in things like Liana, you need the user to know their time locks, how many recovery paths they have, you know, you need to know the different Xpubs, etc. So the wallet descriptor is also something that users should keep. Still a lot of education to do that, and we know they don't do it. So we've been working on a BIP proposal. Well, the community has been working on a BIP proposal. We actually implemented it, the current version in Liana, where you can encrypt your descriptor. So why would you do that? It's for the users to be basically able to store this descriptor everywhere they want on Google Drive or whatever without being afraid that Google will check their wallet balance. Another thing a user could do in this case is like send their encrypted descriptor to a laser engraving service. The laser engraving service engraves this descriptor, ship it back to the user, and the service just doesn't have any clue about the wallet itself, right? So the encrypted descriptor is a pretty good way of making sure users always have a backup of the descriptor without the service that stores them being able to decrypt it. If you're interested, again, there is a discussion on, there is this big proposal on GitHub, but you also have a discussion on delving Bitcoin. So in this case, we're already assuming we can find a way for the users who still have this mindset of, all I have is my mnemonic. They should be able to access this encrypted descriptor online somewhere and be able to access whatever of the derivation path, etc. information that's contained in there. So everything we talked about basically would be assumed to be accessible online, encrypted. And if you want to know more about what I talked about, here is the link for the Delving Bitcoin post, but you can just go on Delving and search for like avoiding Xpub reuse, and you will find it. So I'm pretty much done. I don't know if you have any question. I know it was a lot of content. Maybe it's a bit confusing, so yeah.
Even with the encrypted descriptor, there will be a problem. So imagine that I want to do a wallet right now, right here with you for multisig. Then it means you need to update this encrypted wallet somehow, which seems if you engraved it, seems painful.
So the key we are using for the encryption is actually every single Xpub that is present in the descriptor. So you just need an Xpub to decrypt it as well. So you can get access to your Xpub by having any single mnemonic in your setup. But to encrypt it, you don't need access to any secret. You just need the Xpub, and you already have it, right? Because it's in the descriptor you're trying to encrypt.
But when I'm doing a new wallet with you, like you will use a new Xpub pass, right? Somehow, you don't need to update these states.
You do, yes, but that's not a problem.
Okay.
Because the new key you have, you can already use it to encrypt and send that anywhere, right? To me, to your Google Drive, to whatever.
Okay.
Yeah. So all you need to access this encrypted descriptor afterwards is any single Xpub of the descriptor.
Thanks for the talk, Kevin. I wanted to understand a bit better this problem of your using the same seed words in your business and personal, and then somehow your business guys knowing what your personal stash is. How, I understand if you use the same account, then that would happen. But if you use a different account, isn't that a solution? Why do you need such a sophisticated solution to that?
Yeah, so I'm basically assuming we are deriving this thing from somewhere, right? And so we're going to use the same somewhere to be able to rotate keys. And so that's where the issue is. So of course, it depends. So if I just provide the descriptor to my colleagues, it's fine. But if we use a service, let's say, Nunchuck or Keeper style, that needs to be able to rotate on the server side because of new time locks, etc., then if we use the same kind of route, they can also kind of brute force my other wallets.
I see. It's like a matter of getting them to actually do the derivation all the way down when they give out the Xpub, not just giving out the main one.
Yes. So of course I need to get call it an Xpub. I need to get an Xpub out of my signing device in the first place. But then we're going to use that to be able to generate the unhardened one on a service side or on a single user side of things. So yeah, it really depends on how it's implemented. But I do believe that some services online will want to have this capability of being able to rotate for their users without themselves having any key, just for time lock rotation and things like that.
Okay.
Yeah.
Well, thanks, Kevin.
Thank you.
Awesome.
Bitcoin is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin sovereignty. Run your own node, hold your own key. Bitcoin is freedom, peer-to-peer, on-chain and off. Meet the sovereign builders of tomorrow.
Hello, everyone. My name is Cygnet, and for the last 2 years or so, I've been interested in sign and payments. I think it's going to sort of nerd snipe me for like 2 years now. And more specifically, me together with Sostine, we have been working on a specific type of sign and payments wallet, which we call, I guess, a sovereign sign and payments wallet. So yeah, I'm going to talk about that. But before I'm talking about my wallet and what it's, to give you kind of a good idea of what why it's sovereign, I think it's first important to give kind of a quick overview of what sign and payments itself actually is. And to understand sign and payments, we first need to talk about the problem that sign and payments is trying to solve, which is address reuse. So I'm sure I don't really need to tell the people in this audience that address reuse is something that you generally should be trying to avoid. This was like known, basically from day one. I think technically even before day one, because it was in the white paper that you should not like reuse keys. For privacy concerns. But despite that, address reuse is actually super prevalent. So here are just 2 examples that I screenshotted. So the one on the left here is the donation space for GrapheneOS. Now, GrapheneOS is obviously it's a very privacy-conscious project. So they would, you'd imagine they care a lot about privacy. Yet they on their donation page, they use this single just normal hard-coded Bitcoin address. And of course, if you can essentially, everyone can just look this up and they can kind of see how many people have sent funds to them. So that's one example of, people using, or people often still doing address reuse. Another example is Bitcoin exchanges. So to the right is a screenshot of a Bitcoin exchange. And for exchanges, it's generally just more user convenience. So if you want to withdraw, especially in Europe, it's sort of starting to become customary that you have to verify the addresses that you own, and that is because impartially it's for compliance reasons, but it's also just more convenient. If I'm if I'm a user, I want to to be sort of good. Have good privacy, you kind of just need to verify an address every time you want to withdraw, but nobody does this, so it's much more convenient to just use the same address. So yeah, this is just a big problem, and this is something that sign and payments is trying to tackle, basically. So the way that if I wanted to describe sign and payments in a single sentence, I would say that sign and payments is trying to counter address reuse with the use of ECDH. So ECDH, elliptic curve Diffie-Hellman, it is a cryptographic scheme that is pretty, I guess, popular, and it is like a scheme that 2 parties that have a public-private key can sort of, without really even interacting with each other, they can form a shared secret together. And this requires private and public key pairs. And as it happens, most Bitcoin transactions tend to use public-private keys. So, if you think of a normal Bitcoin, a common Bitcoin script is like sending to Taproot or sending to a witness public key hash, you're basically sending to a public key. And when you spend it, you are actually using the private key to spend it. So there's private-public keys here. And so the idea of silent payments is that we can exploit this fact, the fact that a lot of transactions on-chain are using private-public keys, to create a new address. So this function you can see here, that is kind of in a nutshell what silent payments is doing. So normally you would kind of send to a public key, which is I call P recipient. But now instead of sending it to that directly, what I'm going to do is I'm going to use Diffie-Hellman to calculate a shared secret, and I'm not going to send to the address directly, but I'm going to tweak the address with the shared secret, and I'm then going to send it to that address. And so this is sort of unique per per sender-recipient pair. So that is what creates like or avoids address reuse. So before I continue on, I think I first just want to quickly mention that in a silent payment address, we actually have two different keys. We have a scan key and a spend key. And these are sort of separated out because I'll get into this, but for silent payments, you need to do a lot of scanning, and it's useful to have like a separate key for this because maybe maybe you don't want to always have like the spend key in memory when you do this. There's a bunch of other reasons for it too, but that's the short of it. So yeah, that was silent payments in a nutshell. I'll just quickly go over how you can actually do a silent payment. So first of all, if you're a sender, you need to do use or spend from an output that is using public keys or using public-private key pairs. So these are some script types, which again, this is not a very high requirement because these are very popular script types. So yeah, you need to have at least one of these in your spending transaction. Then, using the private keys from the inputs that you're trying to spend, you sum up the private keys. The reason you sum them up and not just take one at random is because this is slightly more convenient, or this is more convenient to do collaborative transactions. So yeah, you sum up, you create this A, which is the sum of the private keys. Next, you also need an input hash. So the reason here that we take an input hash is because just using the sum of the private keys, it's possible to create transactions reusing the same keys. So you can imagine if you already have an address and you spend from that address twice, you're kind of reusing the key. So just taking creating a shared secret just from the private keys itself doesn't guarantee uniqueness. But we guarantee this by taking this input hash, which is essentially just the out points and then hashed. And because out points are related to UTXOs, and UTXOs can, of course, only be spent once. If UTXOs could be spent multiple times, then that would be like a double spending problem. So that is essentially, that kind of guarantees that this address that we create is unique. So next we create a shared secret. This is the input hash times the A sum times the B scan, which is the scan key for the recipient that you're trying to send to. And then finally, we calculate what the resulting on-chain output looks like with this formula. So P is, you have this shared secret, so you send to the B spend, which in the previous slides would be what you would normally send to, but now we don't just send to the B spend, we also send to a B spend summed up with the hash of the shared secrets multiplied by the generator points and make it a public key. So that is what makes it unique. Then on the receiving side, this looks actually very similar to the sending side. That is because it is actually following the same steps, but now instead of taking, you're sort of doing it from the perspective of the receiver. So on the input side, you're actually looking at the public keys, which is shown with a capital A. So capital A is the sum of the input public keys. And now we have this B scan, which is like a small b, so that is the private key for the scan key. So, however, so the A is the same. The input hash is the same because it follows the same principle. But the shared secret is also essentially the same because this is the Diffie-Hellman scheme. So that also means that in step 5, the resulting on-chain is calculated. You basically arrive at the same result as the sender would. So yeah, that's how a receiver can derive the same address. However, only the receiver is able to spend this address. So you can see at this function at the bottom. Of course, the right side, the hash of the two parties know the shared secret, but only the receiver knows the private key, knows the spending key. So only the receiver is actually able to spend this output. So this is basically how you can do both sending and receiving. Yeah, so in a nutshell, or the way I've just described, it might sound to you like, okay, this seems pretty straightforward. So what is the sort of the catch here? Because if it was that easy to solve address reuse, then why haven't we done this like 10 years ago? So the catch here is that this process, especially for the receiver side, is very incompatible, or it looks like it's very incompatible with light clients. So on the sending side, it is relatively straightforward. All of the extra data that you need it's already part of the transaction. You need to do this extra, like calculate the shared secrets. But other than that, it's not that much extra unique stuff. However, on the receiving side, there's two problems that you need to solve before you can find these addresses. So one of them is that you need extra on-chain data. So we had both this like input hash, and we had like the sum of public keys. This is part of like a transaction. Normally, light clients, they basically just have like a list of addresses that they're interested in, and they have their own ways of finding like if there are any funds on that on those addresses. So like maybe they query like an Electrum server, or maybe they use like a compact block filter or something. But the point is they kind of know what scripts they're looking for. However, in our case, we don't know what those scripts look like. We have to calculate them. And we need like on-chain data for this, or we need this extra piece of data. So we need to be able to provide this to the light clients. And also, another very big problem with silent payments is that, and this is kind of a good thing but also a bad thing, is that silent payments outputs, they look like just any other Taproot output. They're sort of indistinguishable from normal Taproot payments, which is great for privacy, but it also means if I'm a receiver, I don't actually know if a certain transaction, if I look at it, I don't immediately know if it's a payment that is coming for me. The only way for me to figure that out is by assuming, okay, imagine if this was a payment that comes to me, what would like the output script, what would like the address look like? So I would have to do this. I have to go through this like receiving step. I have to take the input hash. I have to take the sum of the public keys. I have to calculate the shared secret. Then I have to calculate the resulting address, and then I check if the address are in the in the outputs of a transaction. Now, 99.9% of the time, that is not going to be the case, because most payments are not for you. But that is the only way that a silent payment wallet is able to determine if you receive any payments. You just have to brute force basically every single transaction there is. So this creates like a huge extra, what we call a scanning step. And we need to you can kind of imagine when silent payments was first proposed, that this was kind of considered a death sentence, that this seems like it's way too much. However, I think for both of these problems there are some mitigations. So the first one is actually not that big of a deal. We need some extra bit of on-chain data. We need two things. We need the input hash, and we need the public key, or the sum of the public keys. So this is something that is essentially all public information, which means that if you want, you can have like some sort of a server that can, for like a given block or whatever, can create like an endpoint that gives this data to you. So this is called a tweak data, or a tweak. This is something that is unique for every transaction. And using this tweak, a recipient is able to calculate a shared secret, because the shared secret was the tweak and the public key sum and the input hash. So this is just enough for any silent payments receiver to create or calculate the actual resulting on-chain address. So that's great. That solves the first problem. Next is the second problem, which is the huge amount of data you have to process. So this is, by itself, seems insurmountable, but one important aspect that is of relevance here is that, if you're a light client, a lot of UTXOs in Bitcoin, they tend to go, or they tend to get, spent pretty quickly. So you can kind of imagine if a UTXO has already been spent, or if a transaction has outputs that are all spent, then at that point, none of those outputs are going to have any financial value. So if you just want to check if you have funds on your wallet, then you don't really even need to scan these types of transactions. So just to give kind of an idea of how much data this can basically save, I did some pretty, I wrote like a script that just kind of looks at the UTXOs from like a range. I think I took like the last 20,000 blocks. I just look at all of the UTXOs, and I looked at how long it takes for these UTXOs to get spent. And as it turns out, from my measurements at least, 50% of UTXOs that get created tend to get spent within 2 days. And after 2 months, 95% of UTXOs that get created get spent again. So that means that if we're a sign-up payments wallet and we want to find out if we want, if we have funds, if the data that we're scanning is more than 2 months old, then we can already basically drop 95% of the data. So that is a pretty huge performance saving. And it can basically be considered that sign-up payments would have been completely infeasible without this. But with this, it seems like it might be possible. And of course, seems like it's kind of this second part of this talk, the point of the second part, which is what we have been working on. So up until what I've mentioned just now was sort of theorized in the sign-up payments BIP, but it wasn't really, like it was sort of theorized that light clients were possible, but it wasn't really like tested out. So this was kind of the reason that we started to work on our project, which we call Dana Wallets. So yeah, we just initially started it just to see like how difficult, how expensive is it actually to create like a sign-up payment light client. And eventually we realized, pretty early on or pretty quickly, like, okay, this to us seems to be pretty acceptable. So now we kind of want to show it to other people, like, okay, this might actually be possible. And so we kind of came to the realization, like, let's turn it into a proper wallet, because that's basically the best way to convince people, is to actually show an example of it. And so, yeah, that's how Dana kind of got formed. Our target use case that we imagined our users to use it for is donations. So donations is a very typical example of like, every now and then you may receive payments to your address. It's not a lot of data, so you don't want it to be sophisticated and run like a full node. You just want to like check maybe every couple of weeks, maybe every month or two. So not very often. But you also, want to make use of this reusability concept that silent payments bring. So that we thought that was kind of like a good target use case. So yeah, we did basically 2 iterations of Dana wallets. In the first one, we kind of built out. Our first iteration was based on 2 software projects. One of them is ElectroS, which is like an Electrum implementation in Rust, and we just slightly modified ElectroS to have like this tweaks endpoints. So this tweaks is what I talked about. It is this minimal amount of data that you need to find outputs. And the other software thing that we used is Nakamoto, which is a BIP158 client. So the process for us in this first version was we first get the tweaks from ElectroS for a particular block. Then we calculate the resulting addresses that we are in, that may possibly have payments, may possibly have like funds on them. Then at that point, we kind of have like a list of output scripts. And at that point, it's kind of very similar to like a normal wallet would be, which is you have like a list of addresses that you're interested in. And you just, in this case, we requested this. We requested like a compact block filter, a BIP158 client filter, and we just checked, okay, is this block interesting to us? If not, we skip it. If it is, we download the block and we scan all of the transactions. So this was, this approach seemed to work. It seems like technically to work. However, we had a lot of issues, like, which are kind of just like probably a consequence of the fact that we were like not that experienced with building for like mobile clients. So we had to run a BIP158 client, which is like a continuous process, and we kind of had to run this in your mobile app. So yeah, this kind of caused a bunch of like overhead or a bunch of this was just a lot more complicated than we probably needed it to be. So the next thing we did was we switched over to another backend, which is called BlindBit Oracle. So BlindBit Oracle is a project by another person in the silent payment space, which is sort of like a minimalist server that you can use to basically, like as a light client, can use to like receive and send. So this is actually very similar to the previous approach, except this time. So a BlindBit Oracle is kind of like a tweak server plus a BIP158 client, but over HTTP. And because HTTP, you know, this is like a much more common procedure in like the mobile space to have like just to make like HTTP requests and responses and, you know, process these sorts of responses. This was actually a lot more manageable for us, so this was really nice. Yeah, the workflow is essentially, it looks very similar to the previous one. So you first get the tweaks. You also query the filter. In this case, the filter, it's not quite a BIP158 filter. It's like a sort of slightly modified filter that only looks at taproot outputs, but it works more or less the same. We calculate the output addresses using the tweaks. Then we check this filter if there's a match. If there's not a match, okay, this block isn't interesting to us. If there is a match, we then use this other query endpoint that BlindBit has, which is like the UTXOs. So you can basically request the UTXOs that are in a specific block from BlindBit. Again, it's slightly modified to make it more compatible or make it easier for silent payment wallets to use, but it's functionally it looks very similar to like a BIP158 client. So yeah, we loop over these simplified UTXOs and we just add the outputs that are interesting to us if we find them. So one important thing to note here is that the first two steps here, the getting the tweaks and getting the filter, those you kind of have to do for every single block. And the third step, which is calculating the output vector, this is the part that is really computationally expensive. So one thing we can do is we can kind of, if we scan block N, we can, while we are processing the tweaks for block N, we can already do web requests for all the blocks that come after it. So that means that basically, you know, networking and computation are sort of done concurrently. So one of these is going to be the bottleneck, and the other one we can kind of do for free if you know, if it's if it's on. So yeah, that was basically the iteration that we use right now. Now I want to talk a bit about what are the actual results of, you know, what we have. So here I have some measurements that I made. So these are benchmarks for how long it takes to scan a certain amount of blocks, a certain block range. So I kind of just used phones that were, you know, lying around. So these may not be like the most representative of what people use, but, you know, this was sort of a nice range for me. On the left side is a Motorola phone, which is a more cheaper phone. It was like a slightly older phone. And on the right is a more high-end phone, Pixel 9. And what this shows here is basically the amount of time it took to scan, like, you know, this amount of data. So I think especially the lowest row is probably the most interesting one. So just looking at the Motorola, for 60 months, which is like 1.25 years, it took the Motorola, the cheap phone, quote unquote, it took it 6 minutes to scan, you know, 60 months worth of data. Now, I think personally that this is totally acceptable. I mean, this is kind of the point where, you know, the technical element sort of drops away. Now it's like more user opinion. Like, what do people think? Do people think that waiting for 6 minutes is acceptable? Now, I will say, like, 6 minutes or this 60 months is kind of like the most extreme case. You know, this only happens when you do like a full wallet recovery, probably. Most of the time, you don't even, you know, you don't need to scan 60 months worth of data. So I think for a worst case, like 6 minutes is pretty good. But of course, that's kind of not really up to me. It's everyone that uses a wallet. They sort of have to decide if this is worth it for them. But yeah, I think these results are pretty nice. I will say one caveat is that this was all using a BlindBit that was running on my same network. So basically, this is more of a benchmark that shows like the computational side, because we assume that if the blind bit is running on your local network, like all of the network stuff is kind of instant. So this is just to show like how long the processing of data looks. So maybe your results may vary, but they always vary, of course, because you can have different hardware, you can have different like network connection speeds. So it does give like a pretty decent picture, at least I think, of the processing time. So yeah, I think. Oh yeah, finally, I just wanted to say, okay, now we have kind of a working light client silent payments wallet. Because we now have sort of access to this reusable address, we can finally start to think about other things that we can do with like a reusable payment code. So yeah, one of the pretty obvious ones is BIP353. So BIP353 is like it's sort of like this email address looking format. This is already in use, I think, like for example, by Phoenix Wallet. This is in Lightning. This is pretty popular, but it is also possible, especially with something like silent payments, it's possible now to also do this on chain. So if you use these BIP353 approach, we can kind of basically create a wallet that just can completely drop showing Bitcoin addresses at all. We can basically create a user experience that is only built around this sort of email address-like user experience. So I think that is pretty cool, and there's a bunch of other improvements that you can think of, but obviously that is yeah, for another time. I think for now that was basically all we wanted to show. So if any of this sounded interesting to you, we really would like to get feedback on our app. We have only been testing it out mostly between ourselves and some people that we talk to. But if you're interested, if any of this sounded interesting to you, please check it out. We have a website here that you can see for more information. We have like an F-Droid repository to download the app. Right now, it's still only on Android, or you have to download the APK, but we kind of want to release it on the Google Play Store and the Apple App Store. So hopefully we can get to that like early next year. But yeah, that was it. Thank you very much. Yeah, I don't know if there's any questions or if...
Awesome. Any questions for Cygnet? Quiet. I don't know. Maybe that's what silent payments has an effect on people. There's not much to say. Great. OK, so we have one last talk on main stage for today. Very excited to have Ava Chow joining us all the way from localhost research in California. While she's setting up, there's some waters left if you guys want to grab a water or a coffee, and we'll get started in about 1 or 2 minutes. There's also, I think now's a good time, we finally got our t-shirts and gift bags are here. So if you'd like to pick up a t-shirt, they're available in the next room along with a bag. I think Shinobi there has one. You can show off as a fancy looking bag that we got shipped all the way from Texas, our print shop. They finally arrived today. Big thanks to Mike from Tempo House for bringing those over. Great, this might be a short turnover then. We've got another half hour here, and then I'll be wrapping up for today. And then we'll be back here tomorrow morning at 10 a.m. sharp. Talk to us about writing a BIP. Thanks.
Cool. Yeah. My talk is titled, You Should Write a BIP, but it's really just me ranting about BIPs for 25 minutes. But I do think that you should write a BIP. I have, over the past 10 years that I've been working on the Bitcoin Core wallet, I've read a lot of BIPs, implemented a bunch of them, and I've also written a large number. I've actually written 18 BIPs, which is the second most number of BIPs behind Peter Walla, who has written 27. That's a lot of text. So, thanks. So first of all, what even is a BIP? Well, you know how when you want to implement something, you might go look for a library to see if someone has already done the work for you? And if you can't find a library, maybe someone has written up like a design, a spec of whatever the hell you want to do. Well, BIPs are those designs and specs. So BIP stands for Bitcoin Improvement Proposal. They're modeled after the IETF's RFCs and the Python enhancement proposals, I think. And really what they are a bunch of documents that describe or that provide information or describe technologies that support and expand the utility of the Bitcoin currency. So this definition is actually extremely vague. Just about anything related to Bitcoin that you can put into words could be a BIP. And we actually have a category of those called informational. So yeah, there are 3 types of BIPs. The one that is most common and the one that I mainly focus on are the specification BIPs. These are BIPs that describe something that you can implement. It can be a new concept, a feature, some standard. Literally anything that you can put into software can be a specification BIP. So that ranges from our favorite fork proposals to peer-to-peer network messages to random other protocols that are relevant like PayJoin to things that are only relevant to wallets like PSBTs or descriptors or hierarchical derivation or derivation paths. All of these fall under specification BIPs. There's a few hundred of them, and they make up the vast majority of the BIPs in the BIPs repo. The second type are informational. Informational BIPs are things that can't really be implemented. They're like just providing extra information that people might want to know about Bitcoin. Some of these are the bits denomination. That's an informational BIP. There's an informational BIP to define Satoshis as the base unit of Bitcoin, or something like that. Like those are all terminology. And then there was a postmortem of the 2013 chain fork that's also an informational BIP. For some reason, that's the only one of its kind there. No one else has written a postmortem of something and proposed as a BIP. So the last type are process BIPs. And these are mainly BIPs 1, 2, and 3. These just describe how BIPs even work in the first place. So the current process is BIP 2, and it's hopefully going to be superseded by BIP 3. BIP 3 is a revision of BIP 2. Some things changed, not a whole lot changed. The process is largely the same, just some different terminology changed, and it's actually a pretty significant improvement. So a very important thing, though, about BIPs is that just because a BIP exists doesn't mean you should do it, doesn't mean it's a good idea, and it doesn't mean that anyone actually endorses it. You can look at the BIPs repo. There's a ton of BIPs that are labeled withdrawn or rejected. These are BIPs that either the author, after writing them, decided that they were a bad idea. That happens occasionally. Or they are BIPs that the community as a whole thought were a bad idea. So extremely important, just because you see a BIP number doesn't mean you should do it. There are a lot of dumb BIPs. I can point some out to you if you really care. I also have some opinions on some BIPs that haven't been rejected, but I think should be. We can get to that later. So what should be a BIP? I really think that there's 2 categories of specification BIPs. The first one is anything that requires software to be compatible. Our most obvious things are fork proposals. There's going to be different people implementing the same consensus rules. We need them to be compatible with each other. And so having a standards document is what enables that to happen. So we see this with fork proposals, peer-to-peer network messages, mempool policy, and and PayJoin, anything that requires different software to talk to each other. The second category is anything that you can implement that might be useful to someone else. And I think this is kind of where people, all of us here in the working wallet space is like, these are the kind of BIPs that we might write. We had a great idea. it worked great for us, and maybe someone else can use this in the future, so we should consider writing a BIP for that in order to share the idea and foster innovation in this space. So a couple examples of these are BIP32, HD wallets. That topic has come up a lot today. There's also been PSBTs and descriptors. Like these things they're useful, but these things are good ideas and can work in a single software by themselves, but by sharing them with others, we are able to create compatibility, and we're able to build new things on top of them. And so yeah, unfortunately in this space, there are a bunch of things that are used in the ecosystem that aren't BIPs, and I think probably should be. So an important thing here is also that BIPs can be written retroactively. So you can create something, have a great idea, deploy it, it becomes widely used, and then decide, actually, I should probably write a BIP for this. We did that with descriptors. Descriptors started out as a Bitcoin Core only document, I guess. And then a bunch of other people started using descriptors. And eventually, like 3 years later, it's like, we should probably write a BIP here and have a canonical standard that isn't just this random markdown file in the Bitcoin Core repo. Yeah, I was going to say, the other example I have is BIP48. Fun fact, if you look at some of the older wallet software, you'll find a mention of this mysterious BIP48. It specifies multi-sig derivation paths, except for about 10 years, BIP48 didn't exist. I was looking through the Trezor firmware repo some time ago. I saw this BIP48 thing. I went to the BIPs repo, and BIP48 doesn't exist. So what the hell even is BIP48? Well, fortunately for us, a couple years ago, someone actually went through the effort of going through all the software that mentioned BIP48 to figure out what they were calling, what were they doing that where they were calling BIP48, and then writing a document for that. So there is now a BIP48. And that's a kind of thing that could happen again with some of these things. So also, not to flame anyone in particular, but there are a couple common themes in this list I'm about to show you. The first one in my list of notable non-BIPs is the Electrum protocol. So the Electrum protocol, is a protocol that's used for light clients to communicate with Electrum servers. And in my experience, there is very little documentation of what the protocol actually is. It doesn't have a BIP, but it's extremely widely used. A ton of, especially mobile wallets, implement Electrum clients, and then there's like 5 or 10 different Electrum server implementations. The documentation that I can find for it is tied to specific implementations, and then also seems to be sometimes implementation specific, like the different implementations of Electrum servers implement some of the functions differently, so there's not necessarily compatibility there. But if someone actually wrote a canonical standard for this, we probably wouldn't have this problem. And yeah, that would be great for all of us. The next one I got here, also Electrum, is the Electrum seed phrase format. This one I think is especially egregious because the Electrum seed phrase format was invented to oppose BIP39. It was invented to oppose something that was already a BIP. So why didn't they just write a BIP for it? I don't know. The docs for this also are basically non-existent, and multiple wallets also implement the seed phrase format, so this would also have been a good candidate to be a BIP. And really, with this list, any of these I think are good candidates to be a BIP, and any one of you could try to write one. Asterisk. We'll get to that later. So another one here is the signed messages format. This was a format that Peter Walla invented in 2011-ish, something like that. And this is also extremely widely used. I think it's less used today, especially since we've moved away from the idea of just keys. But this was a super widely used signed message format. Tons of different wallets implemented it, and there is actually zero documentation for this. The best documentation I can find is a Stack Exchange post from Peter that was written in like 2014, I think. This one does kind of have a good reason. Like, it used public key recovery, which is patented. So maybe we wanted to avoid scrutiny from lawyers about that, but like, who cares? So that's also one that could have been a BIP. And even better, this signed message format had extensions to support SegWit, because it was created before SegWit existed. When SegWit happened, the Electrum guys went and extended it for SegWit, and also didn't document their extension. Great. So there's, of course, also all of our original peer-to-peer protocol messages. All of our new peer-to-peer protocol messages get BIPs, and there are several BIPs specifying new P2P messages and how to use them, when to use them, all that jazz. But none for the original ones that are still widely in use today. Like the version message, adder message, all of these things don't actually have anything specifying how to use them, which is kind of problematic if you want to write a Bitcoin software that interacts with the peer-to-peer network. The best documentation for this is on bitcoin.org, written by Dave Harding about 10 years ago. But like, there's no BIP for them, and if you wanted to write software, it's hard to know what to actually do if you wanted to implement these messages. The last one I got here is Stratum. Stratum is the protocol used by miners to communicate with mining pools, or vice versa. And this one also is actually not documented. I could not find any documentation for it whatsoever. Yeah, I'm getting to that. There's like almost no documentation for Stratum. It is based on the Electrum protocol, but like, you know, how do you actually use it? And like the real way that people actually use Stratum v1 these days is they take like CG miner that was written however many years ago and just like copy and paste this code base all over the place. It's kind of not that great. I have an asterisk there because Stratum actually does have a draft BIP now. Someone has finally opened a PR to the BIPs repo to add a BIP for Stratum after a number was assigned 13 years ago and no document existed. Yeah, the Stratum, if you look at the BIPs README, Stratum is BIPs 40 and 41. These were signed in like 2012, I think, and the document has never existed. Yes. So these are some BIPs these are some things that I think should definitely have BIPs. And if one of you wanted to try to write a BIP, I have some opinions about that. So writing a BIP. How do you write a BIP? Well, the first thing is you read BIP2 or BIP3, preferably both. BIP3 is the new process, as I mentioned earlier. It's not active yet, so you should read BIP2, but really you should read 3 because it'll probably happen soon. And the process BIPs specify a lot of things that are really important, like the formatting. You have to meet certain formatting requirements for a BIP to be accepted. The BIP editors are pretty aggressive about that. And when you are writing something that can be implemented, you should actually implement it. This is apparently a shocking idea to some people, where they come up with an idea, but they don't actually implement it. And this results in some things that actually are specified and completely not implementable. Some of the less well-written BIPs are like, if you think about it for more than like 5 minutes, you'll realize that actually this is just straight up impossible to do. So I highly suggest that you implement your idea first so you can find the bugs that come out during implementation. And also, a BIP needs to have enough detail in order to have enough detail that someone could implement it just by reading the text itself. if you look at like the software BIPs, like Segwit and Taproot, those have a lot of detail. And if you just read the text of the BIPs themselves, you can actually come up with a complete implementation of that feature. And in my opinion, any specification BIP should be like that. I shouldn't need to go into your reference implementation, although that may be helpful. And I shouldn't need to look at your test vectors, although that may also be helpful. You should be able to read the text itself and come up with a compatible implementation. Also, this requirement, like the BIP editors do check for this. It's also why I think that it's important for the BIP editors to be software developers, because when they read the spec, they can, if they're a software developer, they can imagine in their head how would they implement this, and that can inform them as to whether this is in fact implementable. Also, speaking of test vectors and reference implementation, you do need to have them. I think the BIP editors want you to have a reference implementation before they'll merge it, but they'll let you get away without having any test vectors. I have, in fact, written BIPs where I added the test vectors 3 years later. Yeah. So there's a couple sections in BIPs which are more free-form writing. One of them is the motivation section. This really only exists in order to get the point across as to why this BIP matters. There are a couple proposals where the motivation section turned into a 3,000-word essay about the author's opinion on a topic, and about 2,500 of those words were not necessary. Please don't do that. It wastes a lot of time. So yeah, the motivation is really just there to be like, this BIP exists for this reason. You don't really need to expand that much on it. It's not the place to leave an opinion. Similar for the rationale section. The rationale is often used with the footnote syntax, because the rationale is really footnotes about, here is a common question, kind of like, here's a question about some specific thing in the spec, and here's like a couple sentences on why we made that design decision. It's not the place to opine. It's not the place to write more than 50 words probably. So it's also important to get feedback on your BIPs. Both BIPs 2 and 3 do say that you're supposed to send your BIP to the Bitcoin Dev mailing list or to Delving Bitcoin. And the point of this is so that you can get some peer review before the BIP editors need to see it. There's only a few BIP editors, but there's lots of us, and all of us can read things and give our thoughts on it before they go in for more serious consideration. And this is also really important because you might have what you think is a good idea that someone else thinks is an absolutely stupid idea, and maybe you can have a discussion about why and how to resolve this difference. Because especially if you want to get your BIP adopted, you do need to convince other people that your BIP was a good idea. There's also the thing where like you may have had a good idea. Someone else might have also had that idea. You guys could either collaborate to write a BIP, or maybe that BIP already exists, and you don't need to go through all the extra work of creating a BIP if you could reuse something that already existed. The last thing here, please don't use an LLM. Those are the kinds of things that generate those 3,000 words of text that could be cut. If you really know what you're doing, you can use an LLM as a tool. But if you want to write a new BIP, I would just say don't. There's been a lot of LLM-written BIPs that I think are extremely low quality, and all they do right now is suck up people's time. So that's basically it. I do think everyone who is working on software in Bitcoin should consider writing a BIP, and I would say that Bitcoin needs you to write a BIP. Thank you.
Great. Oh, thanks, Ava. Any questions? Oh, a couple. Okay.
if, say for like BIP 68 and BIP 112, I think these are the time lock based ones.
Yeah.
The BIPs themselves do not specify that the transaction version should be treated as an unsigned integer, but the Bitcoin core code typecasted the int32 to unsigned integer.
Someone revised those, I think.
Yes. But
was that someone you?
So if no, that's not me. But I am ticked because Nicholas called it a BTCD bug, when it was in fact a Bitcoin Core bug, because BTCD was following the BIPs and Bitcoin Core was not. So in this, so I'm just venting at this point. But
actually the solution there is for us to have actually defined the transaction format in a BIP that specified what type the version number should have been.
Yes.
And unfortunately, no such BIP exists. You should write that.
You're making me more work. Okay, thank you.
Ava, is there any hackathon prize for anyone who writes a BIP? Is there a hackathon project?
No.
No? Okay.
No.
I have another.
For multi-author BIPs, can a single author unilaterally withdraw it?
Yeah.
Okay, I'm going to be opening a pull request soon.
Or probably, like, the BIP editor, it's I think it's unclear, but probably. Yeah.
Are you going to be around tomorrow if people want to work on
I'll be around.
BIPs for hackathons?
If people have any questions about BIPs, I'll answer. If you want my more hot takes on specific BIPs, I'm happy to give them.
Cool. We have Calvin Scott.
Can you get your BIP number taken away?
Depends on when you think you have a BIP number.
So if like they assigned it and you haven't,
if it's properly assigned in a PR, no. If Luke said it on Twitter, yes.
Okay, I'm just asking for a friend because I haven't replied to the GitHub reviews.
What's a BIP number?
A number that someone made up, assigned to a BIP for easy identification. That's it.
Any more questions?
Who assigns the BIP number? Because I saw some controversy about that.
So the BIP numbers are assigned by the BIP editors. They have, supposedly there's a pattern. Unclear what a pattern actually is, but the 6 BIP editors do discuss among themselves whether something is ready for a BIP number, and then one of them will go comment on the PR and assign it. And BIP numbers are only assigned in PRs.
Are the numbers arbitrary? Is there an ordering system? Is there any logic?
There is some logic. It doesn't really. I mean, it's basically arbitrary.
What BIP would get me a 2-digit BIP number?
So if you do PayJoin v3, I think that'll probably get a 2-digit number if it happens anytime in the next year.
What was this? Sorry, it was if you do what?
PayJoin so PayJoin right now is BIP 77 and 79. I think they'll probably do another one nearby for the next iteration of that. I think the 50s are open. But that might be reserved for postmortems.
Writing a postmortem might get you a...
Yeah, maybe. Yeah.
Any other questions?
Any other questions?
Great. Let's have another round of applause for Ava. Thank you.
All right.
Cool. And that concludes day 1 of programming for Bitcoin++ Sovereignty Edition. Thank you all for coming and participating. We'll be back here at 10 a.m. sharp. I forget who's presenting at 10 a.m. tomorrow, but be here tomorrow. We'll have coffee, but as noted, we don't have breakfast. I apologize for that, so please grab a snack before coming. We'll have lunch at noon, though. So thank you, everyone. See you tomorrow.
Bitcoin++ is standing sovereign. This December in Taipei, join us at the frontier of Bitcoin sovereignty. Run your own node, hold your own key. Bitcoin is freedom, peer-to-peer, on-chain and off. Meet the sovereign builders of tomorrow.